Hello everyone, welcome to my channel. This is 𝐷𝐸𝐾𝐮𝐻, and in today's video, I'll show you how to automate a complete 𝐸𝐻𝐻𝐸𝐴𝑐𝑜PS pipeline from scratch and deploy a sample application on Google Cloud. So here you can see this is the architecture right now we are going to follow. So in this video, we are going to use two different GitHub repositories, one with the application code and second repository with the Helm chart. So first let me explain you the complete setup. So first we are going to install Ubuntu VM on Google Cloud with instance type of E2 medium. So here E2 medium comes with 2 CPUs and 4 GB of memory, but we are going to customize to 4 CPUs and 8 GB of memory, and we are going to create it with 30 GB of storage. Okay, and after we are going to SSH into the VM, and there we are going to install Jenkins, Docker, Trivy, and Terraform on that VM. Okay, and we are going to connect to the Jenkins, and there we are going to create two different pipelines, one for application automation and second is to provision a GKE cluster. Okay, Google Kubernetes cluster. Okay, so now I will explain you the first Jenkins pipeline. So here you can see these are all the stages of the first Jenkins pipeline. So in the first stage, it will take the source code from the GitHub repository. So here you can see this is the GitHub repository. So from this repository, it will take the complete source code. So in the second stage, Jenkins will authenticate with our Google Cloud account using GCP IAM service account credentials. So in the third stage, it will take the source code to the SonarQube analysis to check it was having any vulnerabilities or not. And in the fourth stage, Trivy will scan the file system. So here basically Trivy is a security tool which is used to find different security issues within the file systems, Docker images or GitHub repositories. It is used to find the different security issues. Okay. So in the fifth stage, OWASP will scan all the dependencies of our project. So here OWASP is a security tool. It will generate vulnerabilities like low, medium, high, critical in dependency check. So in the sixth stage, Docker will build the Docker image. It will tag the Docker image with the latest Jenkins build number and it will push the Docker image to GCP Artifact Registry. So here GCP Artifact Registry is a Google Cloud service which is used to store Docker images. So it is similar to AWS ECR, Elastic Container Registry. Okay. So again in the seventh stage, Trivy will scan our Docker image for any of the security issues, and in the eighth stage, it will clone the second GitHub repository. So here you can see this is the second GitHub repository. Let me come out from this. Test K8s is the repository name. From this repository, it will clone the complete source code. So basically, it is a Helm chart. Okay. So let me open this. So in the final stage, that means in the ninth stage, this pipeline will update the build number in second GitHub repository Helm values.yaml file. Okay. It will update Docker build image tag. Okay. So let me open this. So here you can see this is the values.yaml file. So let me open this. Always it will update this image tag. Okay. With the latest build number. Okay. So after completing this first Jenkins pipeline, we are going to create second Jenkins pipeline to create a GKE cluster using Terraform. Okay. And after creating this GKE cluster, we are going to connect to this GKE cluster using Google Cloud Shell. And there we are going to install ArgoCD for our application deployment. So here ArgoCD is a tool that helps to automate the deployment of our applications to Kubernetes clusters by continuously monitoring Git repositories, and it can automatically sync with the new changes. Okay, and after that we are going to set up Prometheus and Grafana for our Google Kubernetes cluster monitoring, and after we are going to install Nginx Ingress controller where we are going to map our IP to a domain provider. So in this video we are going to use domain provider as GoDaddy, and at last we are going to set up SSL and TLS for our secure connection. Okay, so yes, that's it for this project intro. So the main thing is this project is perfect for anyone looking to implement DevSecOps practice in their CI/CD pipelines. And by this, by the end of this video, you will be able to automate deployment securely and efficiently while keeping your Kubernetes deployments up to date with the latest builds. Okay, so now let's do this everything in practical. So here you can see this is my Google Cloud Console. So let's implement everything from scratch. So first let's create a VPC. So directly jump on to VPC networks. And currently we have only two different VPCs. One is default VPC and one is public VPC. So let's create a new VPC network. So directly select here create VPC network. So first you need to provide the VPC network. So let me provide a name like project VPC. Okay, so here you can give the name whatever you want. So here I'm going to select custom. So let me create a single subnet itself. Let me create subnet 1. Subnet 1. And region, here I'm going to select US Central 1 and IP range 10.0.0.0/16 I'm giving, okay. And directly select here create. So now a VPC and subnet will be created. So here you can see project VPC it is creating. Let me refresh this. So in this VPC only, let's set up our VM. Let me refresh this. So meanwhile, let me open Compute Engine in a new tab. So here using Compute Engine, we can create a virtual machines in Google Cloud. Okay. So here you can see project VPC has been created and it will create a single subnet. So you can see subnet 1, US Central 1, and we created with this ADR range. Okay. So now let me create a virtual machine in this VPC. So I will come here and directly select your VM instances. So currently we don't have a single virtual machine. Okay. So here you can see we don't have a single virtual machine. So let me create a virtual machine. Directly select your create instance and let's give the virtual machine name like Jenkins-VM. So in this VM only we are going to install Jenkins, SonarQube and Trivy, each and everything, and Terraform. We are going to set up everything. Okay. So here I am going to select zone as any. By default it will create in this any of the zone. And I'm going to create in US Central 1 region. And here you can see when come to machine type, here I'm going to create with E2 and we are going to customize this. Directly select here customize and I need 4 cores and 8 CPU, 8 GB of memory. Okay. 8. Okay. 7.75 is also enough, no problem. And directly jump on to OS and storage. So here I'm going to select OS as Ubuntu and here I'm going with 20.04 and here directly select size minimum 20 to 25 GB is enough and directly select here select. Okay. And directly jump on to networking and directly select here Hello HTTP and Hello HTTPS. Okay. And here you can see network interfaces. That means we need to select here VPC and our subnet. So previously we created a VPC, right? A project VPC. So I'm going to select that project VPC. And here you can see automatically it is taken the subnet 1. So we created with this ADR. And directly select here create. So now virtual machine will be created. So mostly it takes 10 to 15 seconds to create this virtual machine. Okay. So after creating this, we need to give port 22 access. That means SSH access. So here you can see currently it is in running state. So now we need to give SSH access for this virtual machine. So now directly jump onto this VPC, project VPC, and directly jump onto firewalls and add firewall rule. Name is SSH. And here I'm going to create this under project VPC. And here target all instances in the network and source IPv4 range is 10 0.0.0.0/0. Okay. And TCP which is port 22. Okay. So I'm going to give access to port 22. Directly select here create. Okay. So now a firewall rule will be created with port 22 which is for SSH. Okay. So let me drop down this. So here you can see SSH it is created. Okay. So directly come here and directly select here SSH. So now it will connect to this virtual machine. So I forgot to tell you one thing for our today's video. Already I created a blog on Medium. So here you can see this is the blog link, Google Cloud project. So I haven't completed end-to-end blog. So by releasing this video, I will complete this entire blog. Okay. So let's follow this blog and let's set up each and everything. So this is the source code to install Jenkins. So let me come here and directly select here authorize. So here you can see successfully it is connected to our virtual machine. So always first you need to do sudo apt update. So you need to update this virtual machine. Sorry. So update -y. So it will update this virtual machine and directly became to root user by hitting sudo. So okay, so currently we are in root user and vi jenkins.sh. Let me create a file with jenkins.sh and keep this in insert mode and open this blog. So let me copy this entire code, entire source code. So this will install Jenkins on this Ubuntu virtual machine. Okay, I will paste it here and I will save this. So now, uh, currently for this file, it doesn't having executable permission. So let me give the full permissions for this. So chmod 777 jenkins.sh. So now when I hit ll, it will this file will having full permissions. Here you can see read write execute read write execute for jenkins.sh. So let me execute this file sh jenkins.sh. Okay, so now Jenkins will be installed on this Ubuntu virtual machine. So after installing this, let me open this blog. We need to install Docker and we need to install Trivy and we need to install Terraform. Okay. So here you can see Jenkins has been installed on this virtual machine. So let me see the status of this Jenkins by hitting systemctl status Jenkins. So here you can see Jenkins is active and running. So now let me install Docker. apt install docker.io-y. So it will install Docker on this virtual machine. And after installing this Docker, we need to install Trivy and we need to install Terraform. Okay. So here you can see we need to install Docker, Trivy and Terraform. So if you want to see the source code, so let me see for Trivy. Open a new tab. Install Trivy on Ubuntu. Okay. Directly open this first link. So here you can see this is the source code to install Trivy. Okay. So first let's come here. Let me hit Docker version. Sorry for this Docker version. So here you can see Docker has been installed successfully 26.1.3. Okay. So now let me clear the screen. So now let me install Trivy on this. Let me copy this. Let me come here and let me paste it here. Select here y about. Okay. So now let me do one thing. Let me execute line by line. So first I will copy this first line. I will come here and I will paste it here. Enter. Select here y. And meanwhile let me copy this second line and let's paste it here. Let me copy this third line, paste it here, and now let me update this apt update -y, and at last we need to install Trivy. Have to get install Trivy. Okay, so let me paste it here. So currently we are in sudo user only, so here sudo is not necessary. Okay, let me clear the screen now. Trivy -version. So here you can see Trivy has been installed successfully on our virtual machine. Now we need to install Terraform. Directly close this and open a new tab. Install Terraform on Ubuntu, such like this, and open this first link and let's see. So already we have all these complete source codes in this. Here you can see this is the source code to install Terraform, and this is the source code to install Trivy, and this is the source code to install Docker, and this is the source code to install Jenkins. Okay, so you can directly follow that. So here, let me go back. Let me open this second link. So here you can see we need to install on Ubuntu, right? So directly copy this entire source code and come here and paste it here. So now it will install Terraform on this virtual machine. Let me clear this screen. Now search for Terraform version. So here you can see now Terraform is also installed successfully. Okay. So now let me connect to Jenkins. So in order to connect to this Jenkins, so you need to copy virtual machine external IP. So here you can see this is the virtual machine. Copy this virtual machine external IP. So here I will use incognito window, and here HTTP colon slash slash, and we need to access with port 8080. Okay, by default Jenkins will run under the port of 8080. Okay, so now it will fail, guys. Okay, so when I select here continue to site, it will continuously fail. It will not connect. Why? Because means we need to provide this 8080 port on firewall rule. Directly come here, open this project VPC, and directly jump onto firewalls, and directly select here create firewall rule, and name, let's give the name like Jenkins, and here we are going to create under project VPC itself, and targets all instances in the network, and source IPv4 range 0.0.0.0/0, and specific protocols and ports, which is TCP, and Jenkins port is 8080, right? So you need to provide this port and directly select here create. So it is creating. So let me drop down this. So here you can see Jenkins firewall rule has been created with port 8080. So now let me open this incognito window. So here you can see automatically it is connected to the to here. Okay, so now if you want to get this Jenkins password, directly copy this path and open your terminal, and directly hit cat and directly paste that path. So you can find your Jenkins password in varlib Jenkins secrets and initial admin password. You can find your Jenkins password. Directly select here enter and directly copy this. So this is the Jenkins password, and directly paste it here and directly select here continue. And now here you need to select install suggested plugins. So now some of the plugins will be installed. So meanwhile, let's run SonarQube container. So up to now we haven't run that SonarQube container, right? So we need to run SonarQube container. So now here this is the command docker run -d --name sonar. So here we are going to give the container name as sonar, and -p 9000 port 9000. One is for localhost, one SonarQube runs under the port of 9000, and one is for our localhost, and SonarQube LTS -community. Okay, so first it will search for locally. So if it is not available, it will pull from the Docker registry. Okay, so currently it is pulling from Docker registry. Now when I hit Docker images, so here you will see SonarQube image. So here you can see SonarQube image. So when I hit Docker PS, it will display the SonarQube container which is active and running. So here you can see from last 12 seconds it is running. So here Docker PS is the command to display all the running Docker containers, and here Docker PS -a is the command to display all the stopped containers as well as running containers. Okay, so let me open this meanwhile Jenkins. So here you can see Jenkins has been installed all these plugins, right? So now we need to set up username and password here. So username, let me select Vijay, and password also I'm going to provide Vijay, and confirm password also I'm going to provide as Vijay, full name Vijay, and email vijay@gmail.com, and save and continue. Okay. So here you can see instance configuration. So our Jenkins, so this is our Jenkins URL. So our Jenkins is running on this virtual machine and on this port. Okay. So directly select here save and finish, and directly select start using Jenkins. So Jenkins has been successfully configured everything. So now let me access to SonarQube container. So here you can see currently our SonarQube container is active and running, right? So again, here you need to copy your virtual machine external IP and open your incognito window, and here open with HTTP colon slash slash and with external IP with port 9000. Okay. So localhost we have given port 9000, right? So that's why you need to access with port 9000. By default, SonarQube also runs with port 9000. So again, it will not connect. Why? Because means you need to give this port 9000 on your firewall rules. So now directly jump on to VPC and directly jump on to firewall rules. Okay. So currently we have given access to port 22 and 80 up to now. So now we need to give for SonarQube also. Directly select here add firewall rule and name. Let's give the name like SonarQube. Okay, and we are going to create under project VPC, and here targets all instances in the network and source IP v4 range 0.0.0.0/0, and here specific protocols and ports, which is TCP, and my SonarQube is running on port 9000. Okay, so now directly select here create. So now we have given access to port 9000 also. Let me drop down this. So here you can see we have given port to 9000, which is for SonarQube. Okay. So now let me open this. Automatically it will connect. So here you can see automatically it is connected. Okay. Now initial login username and password is admin, and here also admin. Okay. Login. So now it will ask to change the password. So old password is admin, new password is Vijay, and I'm going to confirm this password with Vijay and update. So here you can see successfully SonarQube is also configured. So now it is up and running. SonarQube is up and running, and Jenkins is also up and running. So now let me install some of the plugins for our today's video in Jenkins. So directly select here manage Jenkins, and here directly jump onto plugins and directly select here available plugins, and here you need to install some of the plugins. So first plugin is Docker. So here you need to install Docker Commas, Docker pipeline, API, build step. Okay, and now let me install Kubernetes plugins, Kubernetes client API, Kubernetes credentials, Kubernetes CLI, Kubernetes credential provider. Okay, Kubernetes pipeline. Okay, uh, let me close this and let me select OWASP. Here you can see OWASP dependency check, and let me search for Terraform. So Terraform is also we have provided. So at last let me select pipeline stage view, so to see our pipeline. Okay, and let me install Blue Ocean plugin also, Blue Ocean, to see our pipeline output in a beautiful way. And the main thing is we need to install SonarQube scanner. Here you can see SonarQube scanner. So you need to install this plugin. So here basically Kubernetes plugins are not necessary. Okay, so in your video, so don't try to implement this SonarQube. So we are not going to use this SonarQube. Sorry, Kubernetes, right? So we are not. So don't provide this. Okay, so after completing this, so if you want to enable email notification on this project, you can directly install email extension plugin and you can directly configure email things. Okay, so in my previous project I have implemented that. So you can directly come here and you can directly search for email extension plugin. So email extension plugin. So there is a plugin called email extension. So using that plugin, you can set up email notifications for your Jenkins pipelines to your email. Okay. So I'm not going to set up on this today's video. So let me directly select here install. So after installing all these tools, we need to integrate all these tools with in Jenkins tools. Sorry, we need to integrate all these plugins in Jenkins tools. Okay. So after installing all this, I will restart this Jenkins. So meanwhile, let me open this blog. So up to now here you can see we installed all these Trivy, Docker, Jenkins and Terraform, and we run SonarQube container, and after that we connected to Jenkins and we install all these plugins, and after completing this we need to integrate these plugins in Jenkins tools. Okay, so I haven't added all the images and everything, so I need to update this blog. Okay, so let me come here. So it is running. So after completing this we need to restart this Jenkins. So here you can see all the plugins has been installed successfully, right? So directly select here restart Jenkins. So now Jenkins will be restarted. Okay. So here you can see it is asking Jenkins username and password. So username is Vijay and password is also Vijay, and directly select here sign in. So now it will connect to our Jenkins. So up to now we installed some of the plugins, right? So now we need to integrate these plugins with the Jenkins tools. So directly select here manage Jenkins and directly navigate to tools. So here you can see directly navigate here to tools, and here you need to integrate all your plugins. So first here you can see Terraform installation. So directly select here add Terraform. So here let me use the name like Terraform. So let me provide our Terraform path. So I'll come here. So let me retry this. So session has been expired. So meanwhile, directly select here authorize. So meanwhile, let's come here. So directly select here Docker installations, add Docker. So here name, let's give the name like Docker, install automatically, add installer. So here download from docker.com. Okay. And after that we need to, so this is the dependency check installation, that means OWASP. So directly select here add dependency check. So let's give the name like dp-check and install automatically, add installer, install from github.com. Okay, so we are going with the latest version dependency 12.1.0. okay, so now here sonar scanner installation. So directly select here add SonarQube scanner. So here let's give the name like sonar hyphen scanner, and here also I'm going with the latest sonar scanner version, which is 7.1.0. okay, so I'm going with this version. So meanwhile we need to integrate Terraform also. So let me open this shell. Okay, now sudo su, it is connected. So now we are in super user. So now here directly search which Terraform. So directly copy this path user lib terraform, user bin Terraform, and directly install directory, provide this here. Okay, so now directly select here apply. So once again I'm showing you. So here first we integrated our SonarQube. So here you can see Sonar Scanner installation. That means our SonarQube. So we are going with the latest SonarQube scanner version, which is 7.1.0. And after that, we are integrated OWASP, which is dependency check installation. So here we have given the name like dp-check. We are going with the latest dependency check version, which is 12.1.0. And after that, we have given Docker installation, and we are going with the latest Docker version. And at last, we are going to provide for Terraform. Okay, so directly select here save. Okay, so now up to now we installed some of the plugins, right? So we have installed plugins and we have integrated on Jenkins tools. So now we need to we need to establish the communication between Google Cloud and Jenkins. So to establish the communication between Jenkins and Google Cloud, we need to create GCP IAM service account credentials. Okay, so we need to create a GCP IAM service account credentials, and we need to provide that credentials on Jenkins credentials. Okay, so now let me open this and let me jump onto my Google Cloud Console, and here let me open IAM and admin in a new tab. So meanwhile, let me keep here. And directly jump on to service accounts. Okay. So here you can see service accounts. Open the service accounts. So currently we have only the single service account, right? So let me create a new service account for our today's video. So directly select your service account and let me give the name like project hyphen service hyphen account. So here the name you can give whatever you want, and after that directly select your create and continue. So now we need to provide permissions for this service account. So here role I'm giving basic and I'm going to provide owner permissions for this, and directly select here continue and directly select here done. Okay, so now a service account has been created. So here you can see project service account we created with this name. So here you can see project service account. Okay, so now if you want to see the permissions which we have given for the service account, so directly jump on to IAM and directly here you need to see. So let me refresh this page. We need to see project service hyphen account. So here you can see project service account. So this is the one we created. So we have given owner permission. So now if you want to add some another roles for the service account, so you can directly select your edit principal and directly select your add role. So here you can see currently we have given only owner permissions. Okay. Now if you want to add some another permission, directly select here add another role. So if you want to provide artifact registry role, search for artifact registry. So you can see artifact registry, it is displaying all the roles. So if you want to provide artifact registry administrator, directly select here artifact registry administrator. So it will automatically add this role. So currently I'm not adding this artifact registry role. Just I'm telling you how you can add the roles to the service accounts. Okay. So directly delete this. Okay. Directly cancel this. So currently we have given owner access for this. Again, where is this project? Here you can see project service account. We have given owner permissions. Okay. So now let me jump on to service accounts once again. From here, we need to download a JSON file. So directly open this project service account and directly jump on to keys. And here directly select add key and directly select here create new key and directly select here JSON and directly select here create. So now a key will be downloaded to our local machine. Okay, that means to our local computer, a JSON file will be downloaded. So let me open that file once. So downloads, and here you can see this is the one. Let me open this. So here you can see, so in this JSON file, it consists the type like service account, and this is our project ID, and this is the private key ID, and this is the private key, and this is the client email, client ID, authentication URL, token URL. Okay, so this all fields are required to authenticate with our Google Cloud account. Okay, so it is similar to AWS IAM access key and secret key. Okay, so now we need to provide this JSON file on our Jenkins credentials. Okay, so let me close this. Let me open this Jenkins and directly jump on to manage Jenkins and directly jump on to credentials and directly select here global and directly select here add credentials. So here kind you need to select as secret text. Okay, so in secret, sorry, you need to select secret file. So here directly select choose file. So here you need to upload your JSON file. So here you can see this is the JSON file we downloaded, right? So directly open this and ID, let's give that ID like GCP hyphen service hyphen account. Okay, so this is the GCP service account credentials, right? So that's why I'm giving the same name, GCP hyphen service hyphen account. So directly select here create. So successfully we provided our GCP IAM service account with Jenkins credentials. So now this Jenkins will authenticate with our Google Cloud account. And the second thing is you need to provide GCP project ID on Jenkins credentials. So in this project we are going to deploy our application, right? So we are going to deploy our application and we are going to provision our GKE cluster using Jenkins, right? So that's why here you need to copy this project ID and you need to provide this project ID on Jenkins credentials as a secret text. Okay, so let me come here and directly select here add credentials and here So currently it is in the text format, right? So here you can see it is in the text format. So here you need to select kind as secret text, and here you need to provide that secret, and here GCP hyphen project hyphen ID. So we are going, so this is the project ID, right? So that's why I'm going to give this name project ID. So description GCP hyphen project hyphen ID. So directly select here create. So up to now we have given GCP service account JSON file as well as this GCP project ID. So now we need to provide GitHub token. Okay. So now let me open my GitHub repository. So this is my GitHub. So directly jump on to settings and directly jump on to developer settings, and here directly select your personal access tokens and directly select your tokens classic, generate new token, and directly select your generate new token classic. So before selecting this, I'm going to delete this old tokens, delete this, and let me generate a new token. So now I need to authenticate my GitHub mobile. So let's wait. GitHub mobile and number is 42. Approve. So now it will open here. Okay. So now here let's give the name like app token. Okay. So expiry I will provide only 2 days. Custom, and I will provide only up to 31st. Okay. So here I'm going to provide access to repo. I'm going to provide full access for this token, guys. Okay. So this copilot and project and admin. So these are all not necessary, but I'm giving everything. Okay. So directly select here generate token. So here you can see a token has been generated. So copy this token. So try to store this token somewhere, guys, up to completing this project. So let me come down. GitHub token. Let me paste it here. Okay. So this is my GitHub token. So let me close this. Let me copy this and let me open my Jenkins. So here directly select here add credentials, and here kind you need to select username with password, and here GitHub hyphen token. So let me copy sorry, we need to paste this password, right? So meanwhile once again I will open this, I will copy this token, I will come here and I will paste it here. So here ID has GitHub hyphen token. So let me copy this, and description also I'm going to provide GitHub hyphen token and directly select here create. So here you can see we have provided our GitHub token also. So now we need to set up for our SonarQube, right? So directly select here manage Jenkins. So now we need to integrate Jenkins with SonarQube and SonarQube with Jenkins, right? So in order to integrate with Jenkins with SonarQube and SonarQube with Jenkins, we need to generate a token from SonarQube. Okay, so directly jump on to SonarQube and directly select here administration, okay, and security and users, and directly select under tokens. You need to select this, directly select this, and token name. Let's give the name like app, and directly select here generate. So copy this token. So you need to provide this token on Jenkins credentials, guys. Okay. So directly copy this, jump onto Jenkins, and directly jump onto credentials. And here you need to provide the token. So directly select here global, add credential. So kind here you need to select as secret text. So okay. So why? Because means currently it is in the text format only, right? So you need to provide in Jenkins as a secret text. So provide that secret text here. So here let's give the name like sonar hyphen token. Let me copy this and description also I'm going to provide a sonar hyphen token and directly select create this to create this. So now we have successfully provided our SonarQube token on Jenkins credentials. So now we need to create a quality gateway. So now directly jump onto again SonarQube and directly select here done and directly select here administration and configuration, and here you need to select webhooks, and currently we don't have any of the single webhook, right? So in order to communicate with SonarQube with Jenkins, you need to create a webhook. So directly select here create. So here name, let's give the name like Jenkins. So here you need to provide our Jenkins URL. So directly come here and directly copy your Jenkins URL up to 8080. Copy this and paste it here. So at last you need to provide SonarQube hyphen webhook. Okay, so you need to provide same like this and directly select here create okay, cube hyphen the book. So directly select here create. So now we need to integrate on SonarQube. Sorry, up to now we integrated on SonarQube, right? So now we need to integrate on Jenkins. So directly jump on to Jenkins and directly select here manage Jenkins and directly jump on to system. So here you need to search for SonarQube servers. So let's wait, it is loading. So here you need to search for SonarQube servers. So here you can see SonarQube servers and SonarQube installation. So directly select here add SonarQube. So name, let me give the name like sonar-server. So here you need to provide your SonarQube IP. So let me come here and let me copy up to 9000 and let me paste it here. So remove slash at the end. So here you need to select your server authentication token, which is our SonarQube token. Okay. So here you can see sonar hyphen token. So directly select this. Okay. So directly apply this and directly save this. Okay. So up to now it is completed, right? Sorry, let me close this and Jenkins and let me check system. Let me check this. Okay, it is fine. Save. Okay, so now we need to write our Jenkins first pipeline. So here you can see we need to write this Jenkins first pipeline for our application automation. Okay, so let me create a Jenkins pipeline. So let me come here, directly select here new item. So here continuous integration automation pipeline. So I'm giving this name. Here name you can give the name whatever you want. So directly select here pipeline and directly select here OK. So directly come down and expand this. So already I have written that pipeline. So I will copy paste that pipeline here and I will explain you entire each and every step. Okay. So to avoid some time I have done that. So let me come down. So here you can see all this we have done. So but we need to create a GCP artifact registry and we need to provide that artifact registry name on Jenkins pipeline. Okay. So here you can see, so this is the Jenkins pipeline. So let me copy this entire pipeline. Copy this and come to VS Code. Sorry, come to Jenkins and paste it here. Okay. So meanwhile, first I will explain you this complete Jenkins pipeline. So here you can see when we write any of the Jenkins pipeline, so always pipeline starts with pipeline. So here we are going to write a declarative pipeline. So here declarative pipeline will divide into various of stages and steps, same like this. Here you can see it is divided into various of stages and steps. Okay. So here pipeline always starts with pipeline and we are going to use agent as any. So these are all the environmental variables. So Google application credentials is nothing but we are so previously we created a GCP IAM service account credentials, right? So we have given same this name GCP service hyphen account. So we are going to take this from Jenkins credentials. So this is the environment name we have given Google application credentials. See, similarly we have provided our GCP project ID, right? So we are going to take this from Jenkins credentials and we have given the name environment name like Google Cloud project. Okay, so in this project only we are going to set up everything. That means let me open this my first project, right? So in this first project only we are going to set up everything. So let me open this pipeline. So this is the image tag. Okay, so always our Docker image will be tagged with the latest Jenkins build number. Here you can see 1.0 current build number. So if you open this second GitHub repository, if you observe this, so let me open this repository and test K8s and directly open here Helm. So values.ml. So here you can see 1.0.10. Always 1 and 0 will be constant, but at last it will change this name. So currently in this currently it is build number 10. So that's why here it is showing 10. So if the build number is 1, it will display 1. So if the build number is 3, it will display 3. Always it will vary from here. Okay. So let me open this Jenkins. So here you can see it will take the Jenkins current build number. So we have provided our GitHub token on Jenkins credential site. So we have passed here, and similarly we have passed our SonarQube scanner, right? So same have provided here. So now I will explain you all the stages similarly same like this. Okay, so here you can see in the first stage we are going to take the source code from the GitHub repository, right? So if you observe here, so here you can see, so in the first stage it will clean the current workspace. Okay, so here you can see from here it is starting. So in the first stage it will take the complete source code from the GitHub repository. Okay, so first let me apply this. That means I'm going to save this. So here I will open pipeline syntax. Sorry for this, I will close this pipeline syntax in a new tab. So let me open my GitHub first GitHub repository. So here you can see this is my first GitHub repository. So here copy your repository URL. So here you can see this is the main branch. Okay, so directly come here, open this and directly search for git and open this git, and here you need to provide repository URL. So this is the repository URL and branch is main. Okay, you need to provide this branch. So again here you can see this is the public repository. So here you can see currently it is a public repository, right? So here you can provide credentials or else you may not provide credentials. So we have given our GitHub token, right? So currently it is public repository, so that's why I'm not giving any of the credentials. So in your case it is a private repository, you need to provide your GitHub token. Okay, so directly select here generate pipeline script. So copy this entire script and come here. So directly remove this entire line, guys. Okay, so directly remove this entire line and paste it here. So okay, so in the first stage it will take the source code from the GitHub repository. So in the second stage it will authenticate with our Google Cloud account using GCP IAM service account credentials as well as with GCP project. Okay, so first here you can see gcloud auth activate service account credentials using our gcloud service account credentials. That means using these credentials, guys. Okay, using these credentials it will authenticate with our Google Cloud, and after that in the second stage it will set our project. So you so we have provided this project ID, right? So we have provided this my first project ID, right? So in this project it will set up each and everything. That means in my first project itself. Okay, so it will not set up in my second project, it will set up only in this my first project. Okay, so now let me open this and it will configure with our artifact registry. Okay, so in the third stage for it will, sorry, let me open this diagram. Okay, so after this we have SonarQube, right? Okay, here it is showing Trivy file scan. Anything is no problem, guys. Okay, so in the third stage Trivy will scan our file system for any of the security issues. Okay, so in the fourth stage it will take the SonarQube, it will take the source code to the SonarQube analysis to check it was having vulnerabilities or not. Okay, so this is the SonarQube stage and this is the quality gateway stage and this is the OWASP stage. Okay, so this is for dependency check. It will display vulnerabilities like low, medium, high, critical. Okay, so in this stage it will build the Docker image, guys. Okay, so this is the main thing. From here to here this is the main thing. So this stage is the very main thing. So here you can see cat Google application credentials. So first it will cat this GCP service account credentials, that means Google application credentials, and it will log into our GCP artifact registry. Okay, So it will log into our GCP artifact registry, and after that it will build the Docker image. Docker build -t. We have given the image like image name like hello. This is the tag name, and currently we have our path here. That means our Jenkins file is in sorry, our Docker file is in the same path, right? So that's why I have given dot. Okay, so it will build our Docker image. So again, in this stage, again it will connect to our GCP artifact registry, and after that it will tag our Docker image, guys. Okay, so this is the artifact registry name. We have given Docker repo. So meanwhile, let me do this parallelly. So let me open here artifact registry. Directly search for artifact registry. So here artifact registry is nothing but artifact registry is a Google Cloud service which is used to store our Docker images. Okay, so directly, so previously I have created this, so I'm going to delete this. This is the old one, so I'm going to delete this. So here I'm going to create a new artifact registry to store our Docker images. So directly select your create repository and directly provide the repository name like docker-repo. Okay, so format we are going to use Docker images, right, to store our Docker image. So directly select your Docker, and here standard, and this is the regional I'm going to select, and I'm going to select regional as US Central 1. Okay, and directly select here create. So now artifact registry will be created on our Google Cloud. It is similar to AWS ECR. Okay, so here you can see docker-repo has been created. So when I open this repo, inside this we don't have a single Docker image. Why? Because means this is a new repository. Okay, so we need to provide this repository name on uh, Jenkins. Okay, docker-repo. So same name I have provided here. You can see Docker repo. So if you are going to create your artifact registry with some other names, you need to update that names here. So here you can see Docker repo. You need to update here, and here you need to update this, and here you need to update, and here you need to update. Here you need to update. Okay. So wherever you see docker-repo, you need to update there. So here you can see first it will tag our Docker image with the latest build number. Okay, here you can see image tag. So here from it will take the image tag. We have given 1.0 current build number. So currently if the Jenkins build number is 1, it will tag like 1.0.1. So if the Jenkins build number is 5, it will tag with 1.0.5. Okay, continuously it will tag with the latest Docker images only for to display our latest changes. Okay, and after that it will push the changes to our GCP artifact registry. That means it will push the image tag with the latest image tag, and after that parallelly it will tag with the uh, name latest, and after that it will push that Docker image also latest Docker image tag one also, and after that it will remove that Docker tagged image as well as it will remove the latest one, and at last it will do Docker volume prune. Okay, so this is the one, and in this stage again our Trivy will scan our Docker image for any of the security issues. So here you can see always Trivy will scan our latest Docker image. So here you can see, so this is the repository name US Central 1 docker.pkg.dev. So if you open this, if you open your Google Cloud Console, so if you open this repository, so here you can find that path, guys. Okay, so you can see US Central 1 docker.pkg.dev, and this is our project ID. So here you can see this is the project ID, and after that so this is the repository name. Similarly same I have given here US Central 1 docker.pkg.dev. It will provide here, in this case it will take our project ID. So this is the repository name. Okay, docker-repo. So here this is our image name, and this is the latest image tag. So okay, always this Trivy will tag the latest always this Trivy will scan our latest Docker image. Okay, so in this stage again it will clean our current workspace to clone our second GitHub repository which consists our Helm chart. Okay, so this is the second GitHub repository which consists our Helm chart. So here you can see this is my second GitHub repository. So Helm. So here you can see test-k8s. So if you observe this pipeline, so here you can see test-k8s is my second GitHub repository which consists my Helm chart. So it will clone this second GitHub repository. So here you can see it will clone this second GitHub repository. That means it will clone this Helm chart, and after that using git commands only we are going to modify this image tag, guys. Okay, so I will explain you this one. I will explain you this stage. Okay, so after cloning the second GitHub repository, first it will set environmental variables like git repo name as test and git username as 𝐷 So in this case, you need to change your username. Okay, and here first it will connect to our GitHub repository by using our GitHub token. Okay, so previously we have created our GitHub token and we have provided our Jenkins credentials, right? So if you observe here, so here you can see GitHub hyphen token we have provided here. So using this token, it will authenticate with our GitHub repository, and after that, it will set this username as well as our email here. Okay, so here in this case I'm giving vijay@example.com, and after that here it will take our username, which is vijay. Okay, so here it will pass this name. So after that, first it will cat our helm values.yaml file. So here you can see, so this is the second GitHub repository, right? So in this repository we have a helm chart with name helm. Okay, so it will go into this helm and it will cat this values.yaml file. Okay, so here you can see, first, it will go into the Helm repository and it will cat this values.yaml file. And after that, it will grep for image. Okay. So in Helm values.yaml. Okay. So let me open this. So it will grep for this line. Okay. For this image, it will grep. And after that, using set command. Okay, using set command we are going to change our image tag. So up to here it will not change anything. After calling, it will change to our latest image tag in values.yaml file. Okay, so you can see it will change with the latest image tag. Okay, in helm values.yaml file, if you observe this, so here you can see up to here it will not change anything, but after colon it will change this image tag with the latest build number. So for an example, if the Jenkins build number is 2, so it will change here 1.0.2. Okay, so constantly it will change with the latest changes. Okay, so for an example, currently today if you are working in first version, so if you are going to deploy your first version, so if you modify the changes, it will create a first Docker image and it will push the Docker image to GCP artifact registry with the Jenkins latest build number. Then in values.yaml file, it will update with the latest Docker tag, right? So here it will change that image tag. Okay, so after modifying this, again it will cat our helm values.yaml file and it will do some git difference, and after that it will add this and it will commit and it will push our latest changes to this repository. Okay, that means it will always modify this image tag only. So then ArgoCD will sync with, we are going to uh, provide this second GitHub repository URL with ArgoCD. So that means we are going to sync the second GitHub repository with ArgoCD. So whenever any changes are detected in the second repository, ArgoCD will take action and it will sync with the, it will deploy with the latest changes to our Google Kubernetes engine. Okay, so this is the things it will happen in background, and in the final stage it will display a sample message like successfully updated Docker image tag for continuous deployment. Okay, so this is only it will happen, guys. Okay, so now let me save this and let me run this Jenkins pipeline. So let me do one thing. So before building this Jenkins pipeline, let me comment OWASP, because OWASP will take nearly 25 to 30 minutes to complete that stage, guys. Okay, so let me comment that. So after this pipeline is green, let me I will run this stage, guys. Okay, so up to here I'm going to comment this OWASP dependency check. Why? Because it takes nearly 25 to 30 minutes to complete this single stage. Okay, so everything is okay. So let me save this and let me select here build now. So here you can see build has been started successfully. So here you can see clean workspace has been completed, git checkout completed. So let me keep it here, console output. So here you can see our pipeline is running. So here you can see Trivy file scan is going on. So here you can see, so in the first stage it is taken the source code from the GitHub repository. So in the second stage it is successfully authenticated with our Google Cloud account, and in the third stage here you can see Trivy has scanned our file system, and in the fourth stage here you can see SonarQube analysis is going on. So let me open this. So here you can see SonarQube analysis is completed and quality gateway it is going. So here you can see quality gateway is okay. So now you can see, okay, pipeline has been failed. So let me check SonarQube first. So let me come here. Let me directly select here SonarQube. So here you can see it is passed and app. So directly open this. So here you can see bugs, vulnerabilities, security hotspots and everything. So you can pass all these bugs and everything with your developers. So they will work on that. So here you can see currently bugs are 0 and vulnerability it is showing 1, security hotspots it is showing 3. So you can continuously verify each and everything detailed report on this SonarQube. Okay. So let me come here and let me check that out failure docker. Okay, here you can see permission denied while trying to connect to docker daemon. Okay, we need to give executable permissions to var run docker.sock. Okay, so here it is displaying permission denied issue. Okay, so let me open this. Let me retry here. Select here retry. Directory select here authorize. So now let me hit here sudo su. Now chmod 777 var run docker.sock. Okay, now let me hit here docker version. Okay, now let me see our container is running or not. SonarQube. So okay, everything is up and running. So now let me retrigger this Jenkins pipeline. Okay, let me close this and let me select here build now once again. Let me open this parallelly console output. So here you can see SonarQube analysis is going on. Now in this stage it will not fail, guys. Okay, in this stage it will build the Docker image. So here you can see successfully it is login to our GCP artifact registry using our GCP IAM service account credentials, and it is successfully created the Docker image, and it is successfully tagged the Docker image and it is pushed to the Docker image. So here you can see tag and push also completed, and after that it will remove our all the Docker images and at last it will do Docker prune. And in this stage again Trivy has scanned our Docker image. So you can see Trivy image and this is the image name 1.0.2. Okay, so it is successfully scanned our second. So currently here you can see our currently again it got failed. Okay, let me check this issue. So currently pipeline build number is 2, right? So here you can see it is updated our tag to 1.0.2. Okay, so but it will not update in second repository. Why? Because means in the final stage it is failing, guys. Okay, so here you can see it is throwing an error here. So it will update same like this, and Trivy has scanned our Docker image, and here you can see successfully it is deleted, it is cleaned the workspace once again, and it cloned the second GitHub repository, and it got failed at GitHub token is type username with password, and it needs to be with the string credentials as expected. Okay, so let me do one thing. Let me open here dashboard. Let me select here manage Jenkins. Directly jump onto credentials. So here we have given GitHub token as username and password, right? So here it is showing to provide like in string format. That means in secret text format. Okay. So let me drop down this. Let me delete this. Directly select here as add credential. So let me copy this GitHub token. So this is my GitHub token. So here directly select secret text, provide the text here, and here GitHub hyphen token. Let me copy this and let me paste in description. Directly select here create. Now let me rerun this Jenkins pipeline. So it is saving, so let's wait. So okay, so we have stored this in secret text format. Now let me open here dashboard. Let me open this pipeline and let me select here build now. Let me open this console output. Okay, so here you can see SonarQube analysis is going on. So everything will start from scratch, guys. Okay, so try to do this video project, guys. Okay, so in end of the application you will not see a big output, so it will display only the simple message, but try to focus on this uh, 𝐸𝐻𝐸𝐴𝐶𝐸𝐿 practice, guys. Okay, so let me come here. So again it got failed. uh, okay, okay, I got that one. So here you can see using set command, it is changing tag number to 1.0.3. So here you can see it is changed to 1.0.3, but it will not update in the second repository. So if I refresh this repository, it will not update here. By why? Because means while it is trying to push, it is failing. So here you can see 1.0.10 only it is showing. So but it is changing to 1.0.3. Okay, so let me do one thing. uh, let me close this. Let me select here configure. Let me come down and let me drop down this and let me come down, and here in this final stage it is failing, right? So let me remove this entire thing. Okay, git push and up to here it is okay. So let me try like this, save, and let me select here build now. So now fourth build is going on. So here you can see fourth build has been started successfully. So in the final step only it is failing. It is modifying our helm values.yaml file also using set command. So let's see now it will update or not. So here you can see SonarQube quality gateway is completed, and again it is building the Docker image. So it will not build this Docker image, guys. It will skip. Why? Because means image has been already built, it, right? So that's why it will skip this everything. So again here you can see now our pipeline is green. So successfully it is updated our image tag with the latest build number, which is build 4, right? That means with the latest changes. So here you can see using set command it is modified to 1.0.4. Okay, so in helm values.yaml file, after that we are going to cat helm values.yaml file. So here you can see this is the thing. Here it is modified to 1.0.4, right? And here you can see successfully it has done git add, git commit, it has successfully pushed, okay, to main repository. So let me check this. So currently 1.0.4, right? So let me come here. So here it is showing 1.0.10. So if I refresh this page, so here you can see in the second repository is updated to 1.0.4. So now we need to do one thing. So we need to create a Google Kubernetes cluster using Terraform. So for that we are going to create second Jenkins pipeline to automate this entire process. That means to provision GK cluster using Terraform and Jenkins. And after that we are going to install ArgoCD in this Google Kubernetes engine. And in this ArgoCD we are going to associate this second GitHub repository. So in first GitHub repository it will build the application code with the latest Docker image, right? So that image tag will be updated in this second GitHub repository. So what we need to do is we need to make this repository as public. So we need to make this artifact registry as public. So first let me do that thing. Let me come this. So this is the artifact registry. So repositories. So this is the repository. So ArgoCD needs to pull our Docker images, right? So we need to make this repository as public then. So directly select here Docker repo. So in this repository, you can find your Docker images. So inside hello, you need to see 3 Docker images, okay, with 1.0.1, 1.0.2, and 1.0.3, and 1.0.4 also, I think. So here you can see 2, 3, 4, and latest Docker image. Okay, so these are all the images. So let me make this repository as public. So directly select here Docker repo, and here show info panel and add principal. So here directly search for artifact registry. Sorry. Here you need to select all users. Okay. And here you need to select assign role as artifact registry administrator. So I'm going to provide artifact registry administrator and directly select yes save. So here you can see, are you sure that you want to make this repository as public? Yes, I want to make this repository as public, right? So that's where you need to select allow public access. So now this repository will be public. So anyone can pull this Docker images inside this GitHub repository. So behind the scene, what will happen means, so in the first Jenkins pipeline, it will always build the Docker image with the latest changes. So when our developer has done any of the changes in the first GitHub repository, then when the Jenkins pipeline is built, it will build the latest Docker image and it will store the Docker image with the latest image tag in the artifact registry, and it will update the tag in second GitHub repository in Helm values.yaml file, right? So then automatically ArgoCD will sync with this second GitHub repository and it will pull the latest Docker image from artifact registry. Okay, then it will ArgoCD will deploy to Google Kubernetes cluster automatically. Okay, so everything is automation, guys. Okay, so let me come here first. So up to now we make this repository as public, right? So let me open this. Okay, so here you can see policy has been updated. So now let me jump onto Jenkins and let me create second Jenkins pipeline to provision GKE cluster. So before provisioning GKE cluster, we have integrated OWASP also, right? So we haven't run that OWASP. Why? Because means it will take nearly 25 to 30 minutes to complete that stage. So let me uncomment that stage. So let me drop down this entire file. So let me select this stage and let me uncomment this. So now I'm going to run this stage. Okay, so this stage only takes nearly 25 to 30 minutes to complete, guys. Okay, so meanwhile let me select here apply, let me select here save, and let me select here build now. Okay, so now again a new build will be started. So let me select here fifth build, console output. So here you can see it is started. Quality gateway is going, SonarQube analysis, and after that quality gateway, and after that it will do OWASP scanning. So before while completing OWASP, let's create second Jenkins pipeline for our GKE cluster automation. Okay, so here you can see OWASP dependency check has been started. So here you can see it needs to scan 2,87,185 records, guys. So it takes nearly 25 to 30 minutes to complete only this stage. Okay, so that's why it will take that much of time. So meanwhile, let me write second Jenkins pipeline to provision GKE cluster using Terraform. So let me select here dashboard and directly select here new pipeline, and pipeline name, let's give the name like GKE-Terraform. Okay, so name you can give whatever you want. So currently we are going to provision Google Kubernetes cluster using Terraform, right? So that's why we are going to here I'm giving the name like GKE-Terraform. So directly select here pipeline, directly select here OK. So now directly come down. So to provision this GKE Google Kubernetes cluster, I stored this entire source code in my first GitHub repository. So here you can see test repo is my first GitHub repository. Inside this repository, I have stored in this folder GKE-Terraform. So if you open this folder, I need to tell something about this folder. So let me open this main.tf file. So in this main.tf file, so currently it will provision a private Google Kubernetes cluster. Okay, but why? Because means, so here you can see first it will provision a VPC network, and after that it will provision a sub network, and after that it will create 3 different firewall rules for our Google Kubernetes communication, and after that it will directly create a Google Kubernetes cluster and it will create a container node pool. So by default it will create a 3-node Kubernetes cluster. Why? Because means we are going to create in regional, right? So it will create a 3-node Kubernetes cluster. Each node it will create with 15 GB and with disk type persistent standard, and we are going to create image type with Ubuntu container ID. Okay, So directly jump onto variable.tf file. So here what you need to do is, so in this so this is my Google Cloud account, right? Similarly you have your own Google Cloud account. So uh, you have to copy your project ID, and you need to update your project ID in variable.tf file. In project you need to update this value, guys. Okay, then only you can able to provision your Google Kubernetes cluster. Okay, you need to modify your project ID. And after that, if you want to provision your Google Kubernetes cluster in US central ones, so directly leave this. So or else if you want to provision your Google Kubernetes cluster in some another regions, you need to provide your region name as well as your zone name. Okay, so don't try to forget this. So mainly you need to change your project ID. Okay, so let me copy this repository URL. So meanwhile, let's come here. So here you can see this is the second Jenkins pipeline. So for this we need to create a choice parameter also. Okay, so to apply and destroy our Google Kubernetes cluster, we need to create a choice parameter. Okay, so let me copy this Jenkins pipeline. Up to here, I'm going to copy this. Let me come to Jenkins and let me paste it here. Okay, so now I will explain you this Jenkins pipeline, guys. Okay, so here also we are going to write a declarative pipeline. So always when we write any of the Jenkins pipeline, here pipeline starts with pipeline, and we are going to use agent as any. So here environments, we are going to use Google application credentials. So in Jenkins credentials we store our GCP service account credentials, right? So this Jenkins second pipeline will authenticate with our Google Cloud account using this GCP IAM service account credentials. So here we are going to use choice parameters. Okay, so let me write this choice parameter also. Directly select here, this project is parameterized, and directly select here add parameter. So here we are going to write choice parameter. So directly select here choice parameter, and name here, let me give the name like action, and choice as apply and destroy. Okay, so if you select here apply, it will create a Google Kubernetes cluster. So if you select here destroy, it will destroy Google Kubernetes cluster. Okay, so here we are going to write this. So I will explain you in this pipeline, guys. Okay, here you can see parameters. We are going to create a choice parameter, right? So that's we have given the choice, and name we have given action, and choices we have given apply and destroy. Okay, so let me write description also here. So choose action, choose action, apply to create GKE cluster, and destroy to destroy GKE cluster. Okay, so here description you can give the name whatever you want. Okay, so here you can see. So in this stage, first it will take the source code from the GitHub repository. So here you can see. So this is the first GitHub repository, right? From this repository, it will take the complete source code. So if you don't know how to add that repository URL, so directly copy this repository URL and open your Jenkins, and let me open pipeline syntax and directly search for Git again here. Okay, directly search for Git and open Git, and in place of repository URL, provide your repository URL. In my case, this is the repository URL. Okay, so you can see test repo.git. So this is the GitHub repository. In this repository, I have my GKE Terraform code to provision my GKE cluster. And after that, you need to provide branch name, which is main. So here you can see this is the main branch. So here we have provided main. So here this is a public repository. So here you can see this is a public repository, right? So you need not to provide any of the GitHub credentials. So in your case, it is a private repository. You need to provide GitHub credentials. So in my case, this is a public repository, right? So that's why I'm not providing any of the credentials. So here you can see I have already the GitHub credentials, but I am not providing. Why? Because means this is a public repository, and directly select here generate pipeline script. Okay. So here you can see it has generated a pipeline script. So directly copy this and directly jump on to here to Jenkins and directly remove this entire line, guys. Okay, directly remove this, paste it here. So okay, so in the first stage it will take the source code from the GitHub repository. and after that it will do Terraform init. So that means it is used to initialize the Terraform, and after that it will do Terraform plan. So here you can see we have written some expression like when parameters dot action is equal to apply, it will do Terraform plan. Okay, so in the fourth stage, when when parameters dot action is equal to apply, it will do Terraform apply. Okay, so here Terraform plan is nothing but it will display the resources what we are going to create, guys. Okay, so in main.tf file, you can see, so if you observe this main.tf file, let me open this main.tf. In this main.tf file we have code to create VPC network and subnetwork, firewalls and GKE cluster, right? It will display all the resources what we are going to create. Okay, so in the fourth stage, when parameters dot action is equal to apply, it will do Terraform apply. Okay, that means it will provision our Google Kubernetes cluster. It will create a private Google Kubernetes cluster, guys. Okay, so in the final stage, when parameters dot action is equal to destroy, it will destroy entire Kubernetes cluster. Okay, so that's why we're going to use choice parameter to provision GKE cluster, to destroy GKE cluster. Okay, so this is the things we need to follow. Okay, so directly select here apply and directly select here save. So meanwhile, let me see second Jenkins pipeline. Let me select this. Sorry, first Jenkins pipeline. So here you can see OWASP Dependency-Check almost 8 minutes 20 seconds has been completed, but still it is in scanning stage. So here you can see only 35% has been completed. So it takes nearly 25 to 30 minutes to complete this stage. So this when we run this second Jenkins pipeline, this second Jenkins to provision this GKE cluster, it takes nearly 10 to 15 minutes to provision this GKE cluster. Okay, let me parallelly run this second Jenkins pipeline also, guys. Then automatically at that point of time, first Jenkins pipeline will be green and second Jenkins pipeline will be green. Okay, so we can save some time. Okay, so meanwhile, let me show you GKE cluster. So we don't have even single Kubernetes cluster. Okay, search for GKE and Kubernetes engine. Open this in a new tab. Let me come here. Directly select here clusters. So currently here you can see we don't have even single Kubernetes cluster. Okay, so now using Terraform, we are going to provision Google Kubernetes cluster using Jenkins, guys. Okay, so we are going to automate it using Jenkins in simple terms. Okay, so let me come here. So let me check this first Jenkins pipeline. It is running. So let me run this second pipeline. So direct. So here you can see GK-Terraform. This is our second pipeline. So here directly select build with parameters, and so here you can see choose action, apply to create GKE cluster, destroy to destroy GKE cluster. So currently we don't have GKE cluster, right? So if you observe this, so here you can see currently we don't have Google Kubernetes cluster. So we are going to create a Google Kubernetes cluster. So directly select here build. So now it will provision a private Google Kubernetes for you. Okay. So let me open this. Let me open console output. So here you can see from the first stage, it will take the source code from the GitHub repository and it will do Terraform init. So here you can see Terraform has been initialized successfully, and here you can see it has Terraform plan. That means so these are all the resources we are going to create. So entire these resources we are going to create. So here you can see it is started creating. So currently custom VPC will be created. That means we are going to create a private Google Kubernetes cluster, right? So that's why we are going to create a separate VPC, separate subnetwork, everything we are going to create from scratch. Okay, let me keep it here. Directly select here VPC networks. Directly refresh this. So here you can see custom VPC has been created with one subnet and with 3 firewall rules. Okay, so let me see this. So here you can see Google container cluster dot primary. That means it is started creating Google Kubernetes cluster. Okay, so let me check this. Let me open this. Let me refresh this clusters. So here you can see Terraform GKE cluster. It is started creating. So let me open this. So here you can see 29% has been completed. So it takes nearly 10 to 15 minutes to provision this GKE cluster. So for this cluster, we have given the name like Terraform GKE cluster. So if you want to see this name, so directly come to this GitHub repository So here you can see Terraform GKE cluster. So this is the name we have given. Okay. So with the same name it is creating. So let me come here. So here you can see 1 minute has been completed. So let me come here to Google Kubernetes cluster. So here you can see 56% has been completed. So it is creating, first it will create a GKE cluster, and after that it will create a node pool. Okay. So meanwhile, let me check for OWASP. Let me come here. So here you can see 49, only 49% has been completed, guys. Okay. So you can see 52% has been completed. So up to now, OWASP has completed nearly 12 minutes. Still, it takes nearly 10 to 15 minutes to complete this, only this single stage, guys. Okay. So let's wait. So let me see this GKE cluster. You can see 1 minute 40 seconds has been completed. So it is completed 2 minutes, okay, for this GKE cluster. So it takes nearly 10 to 15 minutes to provision this GKE cluster also. Okay, I will skip this everything, guys. Okay. So here you can see our both the pipelines are green. So this is my first Jenkins pipeline. So this is the continuous automation pipeline. That means it is continuously built to build the Docker image and to update that image tag in second GitHub repository. Okay, so this is the first Jenkins pipeline, and here you can see, so this is the second Jenkins pipeline to provision our GKE cluster. So here you can see our GKE cluster is showing success. So totally 7 resources has been created. That means VPC network, subnets, firewalls, and GKE cluster as well as node pool. So everything has been created successfully. So now let me check this. Okay. So before checking this, let's see whether this image tag has been updated to second GitHub repository or not. Okay. So currently here you can see currently build number is 5, right? So we need to see 1.0.5. So first let me check artifact registry. So here you can see this is my artifact registry. Let me open this hello. So here you can see 1.0.5 last 1 minute ago only it is pushed. Okay, so image has been pushed to artifact registry. So we need to see in second GitHub repository. So currently it is 1.0.4. Let me refresh this page. And here we need to see 1.0.5. So here you can see 1.0.5 has been updated successfully. Okay, so up to now we have created first Jenkins pipeline, and we have automated our GKE cluster using second Jenkins pipeline, that means using Terraform. And now our GKE cluster is ready. So let me check GKE cluster also. So let me come here. So let me select here clusters. So here you can see our cluster is active and running. So let me open this Terraform-GKE cluster and let me select here nodes. So here you can see, as I said, it is created with 3 node Kubernetes cluster. So these are the 3 different nodes. Okay. So now let me connect to this GKE cluster. So here you can see. So first we need to connect to this GKE cluster, and there we need to install ArgoCD, and we need to sync our second GitHub repository with ArgoCD to deploy our application on Google Kubernetes engine. Okay. So let's do this. Okay. So after completing this, we are going to set up Prometheus and Grafana for our cluster monitoring. And after that, we are going to install Nginx Ingress controller, and we are going to provide Nginx Ingress controller external IP with GoDaddy domain, and to route our traffic with a domain provider. And after at last we are going to set up SSL and TLS for our domain. Okay, so we are at this stage. Okay, so let's install Argo CD on this Google Kubernetes engine. Okay, so Let me open this blog and let me come down. Okay, so here you can see up to here we have completed our two pipelines, right? After successfully creating, connect to this GKE cluster from Google Cloud Shell. Okay, so now let me connect to this Google Kubernetes cluster. So directly select here connect and copy this command line command. Okay, so directly copy this, select here. Okay, and here let me open one another tab, and here let me open Cloud Shell. So this is the Cloud Shell. Okay, so directly select this. Directly select here authorize. And here first let's see nodes kubectl get nodes hyphen o wide. Okay, so it will display all the Kubernetes nodes. So currently we created three Kubernetes cluster, right? So it needs to we need to see three node Kubernetes. Okay, sorry, so we haven't connected to Kubernetes, right? So we just copied this command. Okay, so we just copied this command, but we haven't connected to that Kubernetes cluster. So let me connect to this GKE cluster. Let me paste that command first. Here you can see gcloud container cluster get credentials. So this is the name of the Kubernetes cluster hyphen hyphen region we created in US Central 1, and this is my project ID. Okay, so directly connect to this Kubernetes cluster. So let me hit now kubectl get nodes hyphen o wide. Okay, so it will display all the Kubernetes nodes. So here you can see currently, as I said, we created with three node Kubernetes cluster. It has created three nodes. Okay, so now let me clear the screen. So now we need to install ArgoCD on this Google Kubernetes cluster. So now let me open official documentation. So let me come here and directly search for install ArgoCD. So open this first link. Okay, so I just copied this commands from official documentations and I created this blog, guys. Okay, so here you can see first we are going to create a namespace called ArgoCD, and using kubectl command we are going to install all the ArgoCD pods, deployment services, and secret stateful sets, daemon sets, whatever it may be. We are going to install everything from this ArgoCD GitHub repository. Okay, so you can copy from here also. So let me copy this command. So first it will create a namespace called ArgoCD. Okay, we need to come to Cloud Shell. Sorry, we need to come here. Let me keep it here. Okay, so first it will create a namespace called ArgoCD. Okay, so now kubectl get ns. So it will create a namespace called ArgoCD. Here you can see it is created a namespace called ArgoCD last 4 seconds ago. Now let me copy this second command and let me install here, paste it here and enter. So now it will install ArgoCD on this namespace. Okay, so everything will be installed, guys. Okay, so if you observe this medium blog, I just copy pasted that comments here. Okay, so you can follow this official documentation, or else you can follow this blog also. Anything is no problem. Okay, both the comments will be the same. And after that we need to see kubectl get all hyphen and ArgoCD. That means it will display all the pods, deployment services, secrets, whatever maybe it will display all the things. And after that we need to change this ArgoCD service type from cluster IP to load balancer to access our ArgoCD. And after that we are going to connect this ArgoCD. Okay, similarly like this. Okay, so I will explain you in detail about this. Okay, so let me open this whether it is. So here you can see everything has been installed successfully. So now directly hit sorry, it was laggy, kubectl get all hyphen and ArgoCD such like this, guys. So it will display all the pods, deployment services, secrets, and it may be anything. So here you can see, so these are all the ArgoCD pods, and these are all the ArgoCD services, and these are all the deployments, and these are all the replica sets, and this is the stateful sets. Okay, so now uh, let me clear the screen. Kubectl get services hyphen n ArgoCD. Okay. So now to access our ArgoCD dashboard, you need to change this ArgoCD server from cluster IP to type node port or else load balancer. Okay. So you can directly change to node port or else you can directly change to load balancer. Anything is no problem. Okay. So let me change this service type to load balancer. If you observe this blog here, you can see after installing this, first we are going to change this service type from cluster IP to load balancer. Here you can see by using this command, by editing this, we are going to save change to load balancer. So first let me do this. So when you change this service type from cluster IP to load balancer, automatically in your cloud, if you are performing this in AWS, it will create an application load balancer. So if you currently we are going to performing this on Google Cloud, right, it will create a network load balancer. Okay, so let me open load balancers first. So let me or else okay, let me open here load balancing. So currently here we don't have even single load balancer. Okay, so here you can see currently we don't have even single load balancer. So when I change this service type from cluster IP to load balancer, automatically a network load balancer will be created on Google Cloud. Okay, we need to change the service type ArgoCD hyphen service type from cluster IP to load balancer. So let me do this now. 𝐶TL, let me give some space. 𝐶TL edit service, and we need to copy this service name and we need to paste it here hyphen n ArgoCD. So we created this in ArgoCD namespace, right? So we need to give hyphen n ArgoCD. So now come to bottom of this YAML file, and here you can see type currently is in cluster IP. So now you need to change this cluster IP to load balancer. Okay, so you can see load balancer, right? So let me save this, and it got edited. Let me do 𝐶TL get services hyphen n ArgoCD. So now you can see here you can see automatically it is changed to type load balancer, and currently external IP it is in pending. Why? Because means in background it will create a load balancer. So load balancer will take some time to create, guys. Okay, so here you can see a network load balancer has been created. So let me open this. So let's see the IP address for this. So you can see IP address 34.41.228.117. Okay, let me come here and let me run this command once again. So here you can see 34.41.228.117. That means this is our load balancer external IP. So using this IP only, we need to connect to ArgoCD. So let me copy this. Okay, you can directly copy this and open incognito window. So I'm going to maintain all this in incognito window only, right? So that's why I'm going to use this. Let me open new tab, and here directly hit http:// paste that IP and enter. Okay, directly select here save continue to site, and directly select here advanced, and directly select here proceed with this IP. Okay, here you can see it is connecting to ArgoCD. So here you can see now it is successfully connected to ArgoCD. So now we need to provide username and password. So by default here username is admin, and we need to get this password from Kubernetes secrets. That means from ArgoCD secrets you need to get this password. So now if you observe this blog, here you can see up to now we have done this. We connected to this ArgoCD. So now to get your Kubernetes secret, you need to hit kubectl get secrets hyphen and ArgoCD, and you need to get from that means you need to get your password from this ArgoCD initial admin secret. Okay, I'll explain you this. Okay, let me open this. Now here directly search kubectl get secrets hyphen n ArgoCD. So it will display all the secrets of our ArgoCD. So now you need to edit the you need to enter into this. Okay, now you need to edit this kubectl edit secret, and you need to give the name of the secret. So this is the secret name ArgoCD initial admin secret. Okay, hyphen n ArgoCD. So it is in the namespace ArgoCD, right? So that's why here you need to provide hyphen n ArgoCD. So here you can see this is the ArgoCD password. So directly copy this So currently it is in the base 64 format. That means it is in the encrypted format, guys. Okay. So now you need to decrypt this. So directly come out from this, escape. Okay. Now you need to do echo and you need to paste that encrypted password and directly provide pipe symbol base 64 hyphen hyphen decode. So we are going to decode to base 64. So now it will display the actual password. So here you can see from here to here. It will this is the actual password of ArgoCD. So directly copy this, come to ArgoCD and paste it here. Okay. And directly select here sign in. So now here you can see successfully it is connected to ArgoCD. So let me open this blog parallelly. Here you can see currently it is in the encrypted, right? So we need to decode this to base 64 to get the actual password. So you can decode this using this command echo, and you need to copy that encrypted password and you need to convert to base 64. Okay. So you will get the actual password and you need to provide that password here. So you can directly connect to this ArgoCD. Now here you can see currently we have two GitHub repositories, right? In first GitHub repository we have application code. So in this repository it will build the always it will do SonarQube analysis, Trivy file scan, OWASP dependency check, and always it will build the Docker image with the latest changes, right? And it will update that image tag in second GitHub repository helm values.ml file. So now what we need to do is we need to update this second GitHub repository to ArgoCD. Okay, that means we need to sync this GitHub repository with ArgoCD. Okay, so now let's do this. So currently in my case, let me open my second GitHub repository. Okay, it is here itself. Okay, so here you can see this is my second GitHub repository. So currently this repository is public, guys. Okay, so let me open this. So test K8s. Okay, this is the repository. So currently this repository is public. So we there is not required to provide GitHub access token for ArgoCD. Why? Because means this is a public repository. So in your case, you are using a private repository. First, you need to provide your GitHub credentials with ArgoCD. Okay. So I will explain you like that. Okay. So in case if someone are using private repositories, you need to provide your GitHub credentials. Okay. So first, let's provide our GitHub credentials with ArgoCD. So let me open this ArgoCD and directly select here settings, and here directly select repositories, and here directly select connect repo, and here we need to connect via HTTPS. Okay, so if your repository is private, do this. So if your repository is public, please don't do this. Okay, so directly select here git, and username is hello. Okay, so let's give the hello. Project is default project and repository URL. So here we need to provide repository URL. So this is the second repository. So I'm going to associate the second repository, right? So copy this repository URL, paste it here. Username is Vijay Gidturi. And here you need to provide password. Password is nothing but our GitHub token, guys. Okay. So previously we generated this token, right? So let me copy this. Let me come here and let me paste it here. Okay, so we are not going to provide any TLS sets, right? So I'm not going to provide this, and directly select here connect. So here you need to see successful message. Okay, then only it is successfully connected to our GitHub repository. Okay, so currently it is showing success message, that is fine. So now let me deploy my application. So directly select here application and directly select here add new app. Okay, so before doing this, let me follow this blog. So here you can see up to now we provided all the details, right? In settings we have gone to repositories, and there we selected connect repo, and we provided all the details. See, similarly like this. So now we need to create a new application on ArgoCD to deploy our application on Google Kubernetes engine. Okay, so now here you need to select create application. Okay, and you need to provide all this. So I will explain you all this by doing in practical. So directly select here create application. Okay, so here application name in blog what I have given. Let's see first. In blog I have given hello hyphen helm. Okay, so let me give the same name, hello hyphen helm. So currently we are using helm chat, right? So that's why the for remembering this I am giving hello helm. Sorry, helm I have given hello hyphen helm and project. So I'm going to create on default, and here sync policy I'm going to select automatic sync, and here I'm going to select self heal. And so now if you want to create deploy your application in any of the specific namespace, you need to select this auto create namespace, and here you need to provide your namespace. So in background, what ArgoCD will do is like it will create a namespace, and in that specific namespace only your application will be deployed. Okay. So in my case, I'm going to deploy in the default namespace. That is fine for me. So I will provide the default. Okay. So let me come down, and here repository URL. I'm going to select this repository. So previously we have provided in settings, right? So this is the one. And revision. That means this is the branch name. So my branch is main. So if you observe here, in second repository, so here you can see this is the branch is main. So I'm going to select here main, and path type inside, so this is the helm. Okay, so this is the path. So if you observe this, here you can see helm. So inside this only I have my helm file. Okay, helm chat. Okay, so here you can see this is the helm. I'm going to select this cluster URL. I'm going to select this default service, and I'm going to create in default namespace. So that's why I'm going to select here default. So if you want to create in any of the specific namespace, you need to select here auto create namespace, and you need to select you need to provide that namespace name. So it will create a namespace, and it will, our application will be deployed on that namespace. So here we need to provide our helm values.ml file. Okay. So here you can see, now I will explain you here. So we need to provide this helm values.ml file. So if you select this, automatically it is showing helm value. So I am going to provide this. Now I will explain you. Okay. First, see this architecture, guys. So in the first pipeline, it will always build our Docker image with the new changes, and it will update with the latest build number, right? That build number will be updated in the second GitHub repository helm values.ml file. Okay. So here you can see similarly, here we are going to in ArgoCD. Similarly, we have provided helm values like our helm values.ml file. So if any of the changes are occurred in the second GitHub repository, what Helm will do is like Helm will automatically sync with the second GitHub repository, and it will automatically deploy our changes in Google Kubernetes cluster. Okay, it will enter, it will be automatic. Okay, so now let me close this and let me come down. Okay, everything is okay, and directly select here create. So before creating this, okay, let me do here fastly kubectl get pods. So here you can see hello deployment and hello deployment both are creating from last 1 second. Okay, so let me hit -w, that means watch, it will continuously watch. Let me come here and let me open this. So here you can see currently it is in processing state and it is synced successfully. And here you can see service has been created, deployment it is currently it is in creating state, and endpoint it is created, and replica set it is in creating, and two pods has been creating. Okay, so before showing this, once I will explain you the second repository. So here you can see in templates we have all the YAML files. Okay, so currently this is a very small application, right? So that's why we have only the deployment file as well as service file. So if you open this deployment file, so here you can see we are going to pass all these values from values.ml file. Okay, so here it will pass deployment name, it will pass replicas, here it will pass our image tag, and here we are going to pass readiness probes and liveness probes. Okay, so in service we are going to deploy using service type node port. Okay, so here you can see we are going to pass the service name and service type from values.ml file itself. So if you open this values file, here you can see first it will this is the deployment name, hello deployment, and this is the image. So currently we have this image on GCP artifact registry. So always Helm will ArgoCD will pull this image from GCP artifact registry with the latest image tag. Okay, so let me refresh this. So currently what's the Jenkins build number? So currently Jenkins build number is 5, right? So that's why here it is showing 1.0.5. So this is the replicas, we are going to maintain 2 replicas, and this is the service name, and service type is node port we are going to use. Okay, so now let me see this ArgoCD. So here you can see still pods are creating. Let me come here. So here you can see both the pods are active and running. So now let me clear the screen. Let me cancel this. Let me clear the screen. kubectl get pods. Okay. We have created in default namespace, right? So that's why I'm not giving any of the namespace. Okay. So here you can see two pods has been created. kubectl get services. Now a service will be created with type node port. So here you can see type node port, it is created. Now let me see deployments. kubectl get deployments. It got stuck, so let's wait. It will display a deployment. So here you can see a deployment has been created. Now let me hit kubectl get rs. It will display replica set for our deployment. So let's wait. So here you can see replica set has been created with two replicas. Okay. Now everything has been created. So now let's see in ArgoCD. So let me refresh this page. So here you can see everything has been created successfully and currently app is healthy. So ArgoCD has successfully deployed our application on Google Kubernetes cluster. Okay. So now let me access this application. Okay. So now kubectl get services, hit like this guys. Okay. So now directly hit kubectl get pods -o wide kubectl get nodes -o wide. Okay, let me see. Okay, so let me copy this external IP and you need to access with port 32469. Okay, let me open this incognito window. So http :// and external IP with port what's the port 32469. 32469. Directly select here, enter. So it will not access guys. Okay, why? Because means we need to provide this IP node port to firewall rules. So let me copy this. So let me open firewall rules. That means our VPC. Directly select here VPC network. And open private our GCP VPC. That means custom VPC. Open this VPC. And in firewall rules, in firewalls, directly select here add firewall. And directly provide name as app. And here all instances in the network. Source IP 0.0.0.0/0 and TCP. And this port I need to access and directly select here create. Okay. So now you can access your application. It is creating. So let me drop down this. So let me come here. So here you can see hello everyone from Google Cloud version 0.4. Okay. So now let me do one thing. So let me open this GitHub repository and open this index.html file. So here you can see currently this is the final output guys. Okay, as I said, final output will be similarly a single message like this: hello everyone from Google Cloud version 0.4. So now here you can see what I will do is currently here you can see hello everyone from Google Cloud version 0.4 it is showing. So I will change to hello everyone from Google Cloud version 0.2. Okay, so I will change like this. Then I will run Jenkins pipeline. Okay, then you can see ArgoCD will automatically deploy our new changes. Okay, so I will edit this GitHub repository. So imagine I am a developer. So here you can see imagine I am a developer. I am changing this first GitHub repository. Okay, so I am going to change this to version 0.2. So currently here you can see it is displaying version 0.4, right? So I'm going to modify this to 0.2 and I'm going to select here commit changes and commit changes. So now our changes has been committed successfully. So here you can see version 0.2. So now I will run this Jenkins pipeline guys. Okay, I will come here and I will run this first Jenkins pipeline. Okay, CI continuous automation Jenkins pipeline. So currently here pipeline build number is 5, right? So in GitHub repository also you will see only 1.0.5. So here you can see 1.0.5. So currently we have updated this to version 0.2, version 0.4 to version 0.2. In output currently it is displaying 1.0.4, right? So I will run this second Jenkins continuous integration automation pipeline. Okay, so I will select build now. So now a new Docker image will be created, and it will push that image to GCP artifact registry. From GCP artifact registry, ArgoCD will pull the new changes, and new pods will be recreated. Okay. So let me come down. So SonarQube analysis is going on. So quality gateway is going. So after that OWASP. So OWASP will take in the second time OWASP will not take much time, guys. Okay. For only first time it will take much time, and after that it will not take much time. Okay. So here you can see it got skipped in 10 seconds. So in this stage again new image has been built and it is pushed to artifact registry, and in the final stage it will update that image tag. Okay, here you can see image tag has been updated to 1.0.6 with the latest changes. So let me come here. Let me refresh this page. So here we need to see 1.0.6 now. So let's wait, it is loading. So here you can see in second repository is updated to 1.0.6. So now I will come here. So meanwhile I will close this. I will open this. So currently here you can see it is showing only 0.4, right? So I will select here synchronize. Okay. So now again new deployment and pods will be created. So here you can see currently it is in processing. That means in background it will create a new pod. Let me clear the screen. kubectl get pods -watch. So here you can see one pod has been created. So meanwhile let me open artifact registry. Let me remove this. In artifact registry it will store new Docker image, guys. Okay, artifact registry, it will push the latest Docker image. I haven't shown you that. Directly open here Docker repo. Meanwhile here you can see a new two pods are creating. Let me open this hello. So here you can see 1.0.6. So currently all these images are in the same changes, right? So that's why it is gone with the single line. So we have changed our index.html file, right? Version 0.4 to version 0.2, right? So that's why again it is created with the latest changes, and it is the latest changes Docker image. Okay, so let me come here. Let me clear the screen. kubectl get pods. Let me hit like this. So here you can see our both the pods are active and running. So let me check ArgoCD. Let me, so here you can see it is healthy. Let me refresh this. So here you can see deployment has been created and new two pods has been created. So here we need to see 0.2. So if I refresh this, so here you can see automatically it is converted to 0.2. Okay, so this is how you can implement everything. Okay, so now currently we are manually building this Jenkins pipeline, right? So if you create multi-branch pipeline, then when you modified your source code in the first GitHub repository, that means when you modified anything in the first GitHub repository, automatically this build will happen, guys. Or else currently we are using pipeline only, right? If you want to automatically build this Jenkins pipeline when any changes are occurred in the GitHub repository, then you can implement GitHub webhook. GitHub webhook is nothing but when any changes are occurred in this GitHub repository, then automatically first Jenkins pipeline will run automatically. So here you should not then you may not select here build now, then automatically entire process will happen automatically, guys. Okay, so here you can see currently it is displaying 0.2. Okay, so now we need to do one thing. So now we need to implement, that means we need to set up Prometheus and Grafana for our cluster monitoring. Okay, so now let's set up this Prometheus and Grafana for our cluster monitoring. So let me open this medium. So in this blog I haven't written for Prometheus and Grafana setup. Okay, for this we have some another blog. Let me select here profile. Let me come down. So I will provide this blog link. Here you can see monitor your GKE cluster using Prometheus and Grafana. Okay, so now let's install and set up this Prometheus and Grafana on our Google Kubernetes cluster for our cluster monitoring. Okay, so here we are using Helm charts to provision this Prometheus and Grafana. Okay, so here you can see these are the Prometheus and Grafana Helm charts. Okay, so currently this is the Prometheus Helm chart. So let me copy this Helm chart and let me open my cloud shell. Okay, so now let me hit first Helm repo ls. So it will display all the Helm repositories. So currently we have only the Bitnami repository. Let me clear the screen and let me add this Helm Prometheus repository and let me hit Helm repo ls. Okay, so here you can see this is the Prometheus community Helm chart. So let me come here and let me add this Grafana repository also. So I'm going to copy this. Now I'm going to paste it here. Helm repo at Grafana. Now Helm repo ls. So here you can see we have now Prometheus Helm chart as well as Grafana Helm chart. So now we need to update this. Okay, let me update this Helm charts. Let me hit Helm repo ls. So these are the three Helm charts. So apart of Bitnami, we need Prometheus and Grafana. Let me update this Helm repo update. Helm repo update. Okay, so it will update our Helm charts. Okay, now Helm repo ls. So these are the repositories. Okay, so now let's come down and let me create a namespace called monitoring and I will copy this. So it will create a namespace called monitoring. So in this monitoring namespace only we are going to install this Prometheus and Grafana Helm charts. Now when you hit kubectl get ns, it will create a namespace called monitoring. Sorry, kubectl get ns. So here you can see a monitoring namespace has been created last 12 seconds ago. So now let me install this Prometheus and Grafana on this monitoring namespace. So first let me install this Prometheus Helm chart. Let me copy this and let me paste it here. Helm install Prometheus, community / Prometheus means this is a Helm chart name and we are going to install on monitoring namespace. So that's why -n monitoring we have given. Okay, so now entire pods, deployment services, replica sets, daemon sets, stateful sets, secrets, whatever it may be, everything will be installed on this monitoring namespace using Helm. Okay, so now here you can see it was successfully installed. So now kubectl get all -n monitoring. Okay, so let's wait. So here you can see these are all the Prometheus pods and these are all the Prometheus services. So here you can see alert manager and cube state metrics, Prometheus node exporter. So here you can see there are all the services and this is the daemon set and this is the deployment and this is the replica set and this is the stateful set. Okay, so everything it will be created on this monitoring namespace. So now let me come here and let me install Grafana. Okay, let me copy this and let me paste it here. So now we are going to install Grafana Helm chart on this monitoring namespace. Helm install Grafana. So this is the Helm chart name we are giving and this is the chart Grafana / Grafana and -n monitoring in monitoring namespace we are going to create. And now directly select here enter. So now Grafana Helm chart will be installed on this monitoring namespace. So let me open this blog. Okay, let me come here. Now kubectl get all -n monitoring. Now here you need to see Grafana also with Prometheus. Okay, so here you can see Grafana pod. So this is the Grafana pod and this is the Grafana service and this is the Grafana deployment, and this is the Grafana replica set, and this is the stateful set. Okay, so now let me clear the screen. So let me come to this block. Okay, we have done this. So now here you can see access Prometheus and Grafana dashboards. So to access Grafana dashboard, change Grafana service type from cluster IP to load balancer. Here not only load balancer, you can change to node port also. That is also no problem. Okay, so now we need to hit kubectl get services and monitoring, and we need to edit Grafana service type from cluster IP to load balancer. Okay, so now let me hit kubectl get services and monitoring. So here you can see this is the Grafana service. So now currently it is in the type cluster IP. So now I'm going to change this to type load balancer. So kubectl edit service, and we need to provide the service name here and -n monitoring. Okay. Sorry, I have given wrong name. Monitoring. Something like that. Okay. Now here come to bottom of this YAML file and type currently it is in cluster IP, right? So directly change this to load balancer. Load balancer. Okay, directly save this. Now kubectl get service -n monitoring. Okay, here you can see currently it is changed to type load balancer. Currently it is in pending state. So again in background a load balancer will be, a network load balancer will be created guys in Google Cloud. Okay, load balancing. Let me open this. And here you can see a network load balancer has been created. Let me open this. Let's see the IP. 34.41.228.117. I think this is the old one. Let me come here. Here you can see this is the different IP 35.225.135.170. Okay, let me go back and let me open this first one. First network load balancer. So you can see 35.225.135.170 means, so this is the Grafana load balancer. Okay, IP. So let me access Grafana dashboard. Let me open a new tab and http:// we need to access with this IP. So now it will not sorry, it will access guys. Why? Because means this is a load balancer, right? So if you are going to access with service type node port, you need to provide that node port uh, on your firewall rules. Okay, then only you can access your Grafana service. Okay, so now you need to provide Grafana username and password. So let me open this blog now. You can come down. So here you can see up to now we have done this, and now you can get your admin username and password from Kubernetes secrets. That means from your Grafana secrets. So here you can see you need to hit kubectl get secrets -n monitoring, and you need to edit this Grafana service. Okay, so now let's do this. Let's come here. Let me clear this screen now. Kubectl get secrets -n monitoring. Okay, now you need to edit this service type. Okay, not this. You need to edit this secret to get that password. Kubectl edit secret. Secret name is Grafana. Okay, and -n monitoring. So it is in the monitoring namespace, right? So you need to hit -n monitoring. So here you can see this is the admin username. So currently it is in the encrypted format. So you need to convert this to base 64 to get actual password. So currently, let me copy this admin user and directly hit echo and provide that encrypted password and provide pipe symbol and base 64 hyphen decode. Okay. So here you can see username is admin. Here you can see it is the admin. So let me open this username as admin and you need to get password. Okay. So similarly, let me open this kubectl get secrets -n monitoring. Now kubectl edit secret Grafana -n monitoring. Sorry, I have given some typo. Okay, so this is the admin password. So currently it is in the encrypted format. So now we need to convert this to base 64 to get actual password. Okay, so let me come out from this and again echo and provide that encrypted password and pipe symbol base 64 hyphen hyphen decode. Okay, so here you can see this is the actual password of Grafana. You need to copy up to Y. Okay, now let me open this Grafana and let me paste it here and login. Okay, so now it will connect to this Grafana. So here you can see this is the Grafana dashboard. So we successfully connected to Grafana. So now we need to convert access our Prometheus dashboard. Okay, so now come down. So here you can see to access Prometheus dashboard, change Grafana service type from cluster IP to load balancer. Okay, so here I need to change Prometheus. Okay, that is a small typo. So you need to change this Prometheus hyphen server. Okay, so let me come here, kubectl get service hyphen and monitoring. Okay, let me open this blog and you need to change this Prometheus hyphen server type to cluster IP to load balancer. So here you can see Prometheus hyphen server. Okay, now kubectl edit service and we need to provide our service name which is Prometheus hyphen server hyphen and monitoring. Now you need to change this ML that means service type to cluster IP to load balancer. Okay, so here you can see type currently it is in cluster IP, right? You need to change to load balancer. So now let me save this. Again, let me edit this. Let me come down. So it got stuck. So let's wait. So currently it is in cluster IP, right? Let me change this to load balancer. Okay. So this is the one of the service type and kubectl get service hyphen and monitoring. So here you can see Prometheus hyphen server currently it is in pending state. Why? Because means in background again a network load balancer will be created. Let me select this. Let me refresh this. So here you can see a new load balancer has been created. I think this is the one. Let me open this. 34.173.66.94. We need to see this IP. Let me come here and let me clear the screen. Let me hit once again. So here you can see 34.173.66.94. So this is the Prometheus IP. Okay. So now let me access this Prometheus. I will open a new tab in incognito window. http:// and with this IP we need to access. Okay. Directly select here continue to site. So here you can see it is Prometheus dashboard, guys. Okay, so here you can see these are all the targets. So this is the endpoint Kubernetes service endpoint. So you can find all the details of your Kubernetes cluster from here. So now here we are using Prometheus to scrap all the data for Google Kubernetes cluster. So from Prometheus, Grafana will scrap all the data and it will display in a beautiful visualization. Okay, so let me open this blog. In this blog. Okay, so successfully we connected to Prometheus. So now we need to configure Prometheus data source in Grafana. Okay, so let me add data source in Grafana. We need to add data source as a Prometheus. Okay, so let me come here and directly jump onto Grafana and directly select here connections and here search for Prometheus. Okay, so directly select this and here you need to select add new data source. So data source has been added. So here we need to provide Prometheus server URL. So currently my Prometheus is running in the same URL, right? So let me copy this. I will copy link address. I will come here and I will paste it here. Okay, it is running on this local, right? So that's why I'm going to save this. So directly select save and test. So you need to see this message: successfully queried the Prometheus API. That means this Grafana has been successfully queried with Prometheus. Okay. So now directly open this. Okay. So here you can see we successfully. So now we need to import some of the dashboards. So here we have three different dashboards, which is Kubernetes cluster monitoring, which is dashboard number 315. So these are all the pre-built dashboards. Okay. So let me add this dashboards. So directly jump onto Grafana, and here directly select here dashboards, and here directly select here new, and directly select here new dashboard, and directly select here import a dashboard. So currently we are going to import a dashboard, right? So that's why I'm going to use that to save the dashboard. Yes. Okay. Okay, not this. Okay. So here we need to provide dashboard number. So let me provide dashboard number is 315, which is for Kubernetes cluster monitoring. So let me provide here 315 and directly select here load, and directly select here data source as a Prometheus. So from Prometheus, Grafana will scrap all the data, right? So that's why you're going to use as Prometheus, and directly select here import. So here you can see this is the cluster memory usage, cluster CPU usage, and here it will display each and everything, guys. So you can see up to now we have used 4.8 GB, and this is the total GB. So it will display each and everything for our all the pods. So currently we are going to refresh for every 5 minutes. So currently we are going to see for every 5 minutes data. So if you want to see last 1 hour data, directly select here last 1 hour. You can see last 1 hour data. Okay. For every 5 seconds it will monitor, guys. Okay. So now let me add second dashboard, which is Kubernetes monitoring, which is for API server, kubelet, and etcd and etc., which is dashboard number 6417. Okay, let me select here new dashboard and import dashboard. Discard. I forgot it that. What's the dashboard number? 6417. 6417, and directly select here load, and here data source as Prometheus and import. Okay, so it will import that second dashboard. So here you can see pod cluster usage. So let me select here every 5 minutes, and here I'm going to change for every 5 seconds. So let's wait. It is currently loading. So currently for every 5 seconds. Okay. So here you can see currently we have 23 replica sets, and all the here it will display in the default namespace as well as in all the namespaces, right? So here you can see currently it is created with the 3-node Kubernetes cluster. It is displaying 3, and deployment replicas we have 23. Deployment replicas 23. Again it is showing, and total number of pods it is running 44, and total containers it is running 76. Here it will display each and everything, guys. Okay. So this is the one of the dashboard. So let me open one another dashboard, which is 1860, which is Note Exporter Full View. Let me open this new dashboard, import dashboard, discard 1860, and directly select here load, and here data source as Prometheus, and directly select here import. So here I'm going to provide for every 5 seconds, and every I need to see every 5 minutes data, last 5 minutes data. So here you can see it is displaying last 5 minutes data. So currently we have 3 different Kubernetes nodes, right? So these are the 3 different nodes. So this is node 1, and this is node 2, and this is node 3. For every node there is different types of CPUs and memory. So here you can see for this system load is very high. For this node system load is low, but RAM is very high. So for this RAM is high and system load is low, root file system is high. Okay, so for every 5 seconds it will continuously monitor. This Prometheus will scrap all the data from our Google Kubernetes cluster, and from Prometheus Grafana will scrap all the data, and it will display same like this. Okay, so we enabled in this project we have integrated monitoring also. Okay, so now uh, here up to here it is completed, right? So now we need to set up Nginx Ingress. We need to set up install Nginx Ingress controller and we need to divert our traffic to uh, a domain provider. Okay, so let me close this and let me open this. So let me come here. Okay, Prometheus and Grafana setup is also completed. So let me open one file in downloads. I have that file. So Nginx Ingress controller. Okay. So previously I created this documentation. Okay. So if you want to see that, so I have written everything in this blog itself. Okay. So let me open the stories, GCP Cloud Project, Google Cloud Project, and at last you can see that. Okay. So go to bottom of that blog. Okay. So here you can see up to here we implemented this everything, and we integrated, that means we implemented Prometheus and Grafana for our cluster monitoring. So now we need to install Nginx Ingress controller, and we need to provide that Nginx Ingress controller external IP with a domain provider. Okay. So when you create any of the Nginx Ingress controller, it will create, by default it will create a load balancer. So if you are implementing this on AWS cloud, it will create an application load balancer. If you are implementing on Google cloud, it will create a network load balancer. Okay, both will be the same. Let me drop down this. Okay, let me open this. Okay, what's this block? Okay, so this is the repository, Helm repo. Let me copy this blog only, guys. Okay, so then there will be a good idea. So let me copy this. So we are going to add Nginx Ingress controller Helm chart. So let me come here. Let me clear the screen. Let me hit first Helm repo ls. So currently we have three Helm repositories. One is Bitnami. Apart of this, we have Prometheus and Grafana. So now we are going to add Nginx Ingress controller Helm chart. So actually I copied this all commands from artifactregistry.io. So there you can find all the Helm charts, official Helm charts, guys. Okay. Sorry, artifact registry hub. Okay. Artifact hub. So from there you can find all these Helm charts. So now Helm repo ls. So here you can see we have Nginx Ingress controller. So let me update this. Helm repo update. We have updated this successfully, and let me install this Nginx Ingress controller. Okay, we will paste it here. Okay, so here you can see Helm install Ingress-Nginx. We are going to provide this name for Helm chart. So this is the chart name, Ingress-Nginx, Ingress-Nginx, and this is the namespace we are going to create. We are going to create an namespace called Ingress-Nginx hyphen create hyphen namespace. So currently we don't have this namespace Ingress-Nginx. So what this command will do is, first it will create a namespace called Ingress-Nginx. In this namespace, it will create this Nginx Ingress controller. Okay. So let me hit here enter. So let's wait. So after completing this, we are going to see all the pods deployment services on this Ingress-Nginx namespace. Okay. It is still downloading. So let's wait. So here you can see successfully it is installed. So let me hit Helm ls Helm list. Okay, it is not showing. Helm ls -a. So here you can see this is the Ingress. Okay, this is the Helm chart we install right now. So now let me hit kubectl get all -n Nginx Ingress. So it will display all the pods, deployment services, replica sets, and everything related to this Ingress-Nginx namespace. Okay. namespace. Let me copy this. kubectl get all -n. So here you can see for Nginx Ingress controller, so this is the pod and these are the services and this is the deployment and this is the replica set. Okay, so now when you create any of the Ingress controllers, that means when you install any of the Ingress controllers on any of the cloud platforms, by default it will create a load balancer. Okay, so if you are going to create on AWS, it will create an application load balancer. So currently we are going to create this on Google Cloud, right? It will create a network load balancer. So this is the network load balancer IP. So now we need to provide this IP to our domain provider. So in my case, previously I purchased a domain name on GoDaddy. So with the name 𝐵𝑗𝐺𝐻𝐿.in. So now I'm going to associate this external IP with my domain provider, which is GoDaddy. Okay. So now let me check here load balances. So here you can see a load balancer has been created. Let me open this. So you can see 34.136.150.234. So let me come here. 150.234. Okay, so this is the IP of our Nginx Ingress controller. So let me explain you the functionality of this Nginx Ingress controller. Let me open this. So if you observe this diagram, okay, so currently we installed Nginx Ingress controller on our Google Cloud, right? So when we install Nginx Ingress controller, it will by default it will create a load balancer. So now you need to provide that load balancer external IP to your GoDaddy provider. In my case, currently I am going to provide on GoDaddy. Okay, so I'm going to associate my IP to GoDaddy. So when you hit vjgit3.in, first that request will come to Nginx Ingress controller. From there, it will go to Ingress. So in Ingress, we are going to provide our service, right? From service, it will go to our pods. So here, this is the functionality, guys. Okay, this is how it works. So now let me open GoDaddy platform. Let me open here GoDaddy. Let me open this. And my products, directly jump onto my products and open this. And directly jump onto domain, and here directly select manage DNS. And here you need to update your IP, guys. Okay, so here you need to provide Nginx Ingress controller external IP. Okay, so directly I'm going to edit this. So currently it is in IPv4 format, right? So that's why it is an A record. Okay, so currently sorry, I will come here. So I'm going to copy this Nginx Ingress controller external IP and I'm going to provide it here. So currently this is an IPv4 address, right? So that's why I'm going to provide A record. So in your case, if you are providing uh, application load balance external IP, so there you need to provide CNAME. Okay, now here I'm going to provide at the rate and directly I'm going to select here save. And meanwhile, let me open installations and here DNS propagation checker and here vijay.git3.in and a record and search. So let me search whether my IP is able to ping or not. Directly update DNS records. Continue. So now 150.236, right? So let me cross check this once again. 150.236. Okay. So this is our Nginx Ingress controller external IP. So now we need to see here. At last 150.236. Okay. So it is not updated. In DNS propagation checker, you can see everything. Okay. So let's wait, guys. So it takes some time. So meanwhile, let's do one thing. Okay, first we need to set up this, right? After that only we can set up Ingress and everything. So let's wait. Let me refresh this page and let's see. 150.236. Let me refresh this. In single region also still it is not updated. So sometimes it takes more and more time, and sometimes it will complete in less than 5 minutes, guys. Okay, we need to wait for that time. So meanwhile, let's update our Ingress files and everything. Okay, so meanwhile, let me open this file. So here you can see up to now we installed Nginx Ingress controller, and we provided our IP in GoDaddy, okay, as an A record. And after that, let me show you the Ingress class. I forgot it to show you. Directly hit kubectl get Ingress class. Okay, so currently here we are using Ingress class as Nginx. So here you can see Nginx. Okay, so now let me jump on to directory called applications. Okay, so here let me create a file called VM ingress.ml. So it got stuck. So let's wait. Okay, enter and keep this in insert mode. So now, meanwhile, let me check this. Single region also it is not updated. So let me do one thing. Let me delete this, delete record. Add record. So here I'm going to choose a record and at the rate, and let me copy external IP once again. Let me come here. So meanwhile I will save this file. kubectl. First let me hit helm ls-a kubectl get services -n. So this is the service name. Okay, this is the namespace name. So let me copy this external IP 150.236. 150.236. Okay, let me come here and let me paste it here and directly select here save, and now let's see. Okay, successfully it is updated. 150.236. So here you can see 150.236 it is updated in Germany. Okay, slowly now it will update in every region, guys. Okay, so we need to wait for that time. So meanwhile let's set up Ingress file. Okay, so now without wasting time, let me select copy this Ingress, copy this. Okay, let me open this Google Cloud and ls. So let me open this Ingress file VIM ingress.ml and keep this in insert mode, and let me paste it this and port. Okay, why it is coming like this? Okay, let me remove this entire thing. So let me come here. Okay, let me copy this. Let me come here and let me paste it here. Okay, so here you can see API version is ingress.kubernetes.io, and kind we are going to use as Ingress metadata and name. So this is the Ingress name we have given hello-ingress. Okay, so this is the annotation we have given, and previously we installed Nginx Ingress controller, right? So this is the Ingress controller name we are using as Nginx, and this is the host name vijaygudu3.in. So currently previously I purchased a domain name called vijaygudu3.in. So I have provided my Ingress controller external IP to this GoDaddy provider, right? So now when I hit vijaygudu3.in, this request will go to GoDaddy domain provider to this IP, and from there, let me open this. When I hit vijaygudu3.in, it will go to domain provider called GoDaddy, and it will fetch this IP. That means our IP. This is the IP. It will fetch this IP. From there, it will go to Nginx Ingress controller. So previously we installed Nginx Ingress controller, right? The traffic will go to Nginx Ingress controller. From Nginx Ingress controller, it will go to Ingress file, guys. Okay, so this is the Ingress file. So let me open this. So to Ingress it will go, and it will go to this service, hello-service. So previously we have given the name like hello-service only. Similarly, we have given this service name, and our service is running on port 80. So you need to provide this. Okay. So I will see cross check once again. kubectl get services. Okay. So you can see hello-service we have given, and it is running on port 80. So now ls cat ingress.ml. Okay, so here you can see we have given the same service name hello-service. So you need to update your service name, and you need to update your domain name, and here you need to update your port. Okay, so now let me cross check this once again. Let me refresh this 150.236. So here you can see in mostly every region it is showing. So let me check in India. So India it is showing 25.234. So I think we can't access. So let's wait for some time, or else let me apply this file. Ls kubectl apply -f ingress.ml, and here you can see ingress has been created. So now kubectl get ingress. So here you can see ingress has been created, and it is mapping to host vijayagirturi.in. Okay, so now kubectl describe ingress, and name of the ingress is hello-ingress. So here you can see it is host we have given vijayagirturi.in, and it is redirecting our traffic to our service backend services hello-service, and it is running on port 80. Okay, so now let me come here and let me refresh this. 150.236. Okay, in so many regions it is updated. So let me open incognito window, and here http://vijayagirturi.in. So here we need to access our site. So here you can see successfully we are able to access our site. So here you can see it is mapping to vijayagirturi.in. So now let me close this now. I will keep it here. I will keep it here, and I will close this. Okay. So here you can see now we are successfully accessing our application on vijayagirturi.in. So now what we are going to do is we are going to set up SSL and TLS for our domain for secure connection, guys. Okay, so let's do this everything. Uh, Before doing this, let's do one thing, or else let's do this everything. Okay, after completing everything, let's run our application once again. Okay, so let me come here to this terminal. Okay, so let me select here ls. So cat cluster issuer.ml. So here to convert our site, so here you can see currently our traffic is going to HTTPS. Currently that means sorry, HTTP. Currently it is not secure. So to convert our site to HTTPS, here we need to configure SSL and TLS certificates to our domain. So to achieve this, here we are using a set manager to automatically obtain and manage SSL and TLS certificates through Let's Encrypt. Okay, so let's do that everything. So let me open blog. Okay, so here you need to copy this jettrack one, that means set manager. Let me come here and let me paste it here, and Helm repo ls. Let's see whether it is having or not. So here you can see jettrack. Now let me update this Helm repo update. So I'm going to update this repository. Okay, all these repositories. So now I will open this. and let me apply set manager CRDs. Let me paste it here and enter. Okay, it is showing some error. Let me open my blog once. Okay, from blog, let me copy this and let me paste it here once again. Okay, and after that we need to install set manager using Helm. That means our chat stack Helm chat. Let me come here. Okay, let me paste it here. Enter. We are going to install this set manager Helm chat. So for this Helm chat, we have given the name like set manager itself. Okay. So you can see all this set manager namespace. So let me copy this. So it is successfully installed. So now let me clear the screen Helm ls-a. So it will display all the installed Helm chat. So here you can see set manager Helm chat also installed. So let me clear this screen, or else let me see all the pods deployment services for the set manager 𝐾𝐞𝐯 get all -n. So it got stuck. So let's wait. So sometimes this terminal is stuck, guys. Okay, AGR. Okay. So here you can see these are all the pods for set manager, and this is the services for set manager, and this is the deployment for set manager, and these are the replica sets for our set manager. Okay. So now what we need to do is we need to configure a cluster issuer for this Let's Encrypt. Okay. So here cluster issuer is nothing but cluster issuer is a resource that defines how set manager will obtain certificates, guys. Okay. Example from Let's Encrypt. So let me show you that file. So I have that file cat cluster issuer.yml. So here you can see. So this is the sample cluster issuer.yml file. So I'm going to apply this kubectl apply -f cluster issuer.yml. So already I have all these files on this blog. Okay. So here you can see this is the cluster issuer.yml file. So directly provide here any of the dummy email. Okay. After that we need to apply this, and after that we need to update our ingress resource for HTTPS. Okay. So let me come here. So here you can see it is created successfully. So now let me update Ingress resource for our application. That means our Ingress file, right? Ingress file, guys. Okay. So previously we applied this Ingress file. So in this Ingress file we haven't provided any of the TLS sets and everything. So now let me cat this update ingress.yml. So this is the file. So you can see API version networks.kubernetes.io, and kind is ingress, and metadata and name, same name we have given hello ingress. So let me cross check this kubectl get ingress name hello ingress. So same name we have given here, and here we have added one another annotation, which is force SSL redirection. That means we are going to divert our traffic to only HTTPS. Okay. So we have provided our cluster issuer. Okay. And here we are added a block for TLS. So here you can see TLS host we are going to pass for vijayagirturi.in, and this is the secret name vijayagirturi TLS. Okay. So we just added this block for our secure communication. So here, okay. So let me apply this. Okay. kubectl apply -f update cluster issuer.yml. So it is updated successfully. So now set manager will now request a certificate from Let's Encrypt. Okay. So we can check that status from by running these commands. Okay. So this is the command kubectl get certificates. Okay. So here you can see a certificate has been generated to our domain. Okay. Now kubectl certificates kubectl describe certificate and provide this certificate name vijayagirturi-TLS. So here you can see issued certificate as secret does not exist. Okay, stored in new private key in temporary secret resource. Okay, so created new certificate request resource 𝐷𝐸𝐾𝐠 TLS. The certificate has been updated successfully and it is issued. Okay, it is issued. So now let me access our application. So now we need to access our application at Vijay HTTPS. Okay, let me come here and let me just, so here you can see currently it is showing not secure. So when I refresh this, automatically it will redirect to HTTP. So here you can see now when I select this, here you can see connection is secure. So now our domain is secure. Okay, let me open this. Certificate is valid. So here you can see you can find all the certificate details here. Okay, so now everything end-to-end application is completed. Okay, so now let me test this application once again. I will modify this GitHub repository and I will run this first pipeline and I will sync this second. I will sync this ArgoCD. Okay, and you can see your changes in end of the application. Okay, so currently it is displaying only 0.2, right? Let me open this. So here you can see it is also having hello everyone from Google Cloud version 0.2. If you select this, hello everyone from Google Cloud version 0.2. Okay, so currently our connection is also secure, end-to-end application is secure. So now let me come here and let me update this. Hello everyone from Google Cloud version. Let me give the name like final. Okay, so just I'm giving the name, providing here final, and let me commit this changes. Commit changes. Now let me run first Jenkins pipeline. Okay, let me open this incognito window and let me run this first Jenkins pipeline and let me select here build now. Now sixth build will start, guys. Okay, so before here we need, currently here you can see there is this second GitHub repository. In second GitHub repository currently it is 1.0.6. Okay, so let me show you guys. Let's wait, it is still loading. Here you can see 1.0.6. So after this pipeline is green, you can see 1.0.7. Why it is not building? Okay, I think my internet connectivity is bit low, so that's why it is not showing. Let's wait. It is loading. So let me close this. Let me select your dashboard and let me select this first Jenkins pipeline. And I think this pipeline will be green. So here you can see it is green. So here you can see seventh build is also success. So let me retrigger this. Okay, already in Helm values.yaml file it will be updated with the latest changes. Okay, so you can see when I refresh this, here you will see 1.0.7. So you can see 1.0.7. Okay, for to view our pipeline for our satisfaction, let me select here build now. So here you can see now eighth build will start. So here you can see eighth build has been started. So entire repository will scan using Trivy, using SonarQube and using OWASP. Okay, for dependency check, and it will build the Docker image with the latest changes and it will push to artifact registry, and in the final stage it will update with the latest image tag. Okay, so here you can see OWASP checks are going on. Let me open console output. So here you can see in this is the final stage. Here you can see pipeline is success. So it is updated with the latest tag which is 1.0.8. Okay. So here you can see this is the 8 build, right? So that's why it is updated to 1.0.8. Okay. So now let me close this and let me open this repository. So here is 1.0.7, right? When I refresh this, it will update to 1.0.8. So here you can see 1.0.8. So now Let me open artifact registry. Let me remove this artifact registry and open this artifact registry. And here you can see Docker repo. Directly open this. So we need to see 1.0 7 and 8 in a new tab. Okay, 7th built and 8th built in a new line. Okay, so here you can see we have changed changes, right? So that's why it is created in the new line. That means this is the new Docker image. 1.0.7 and 1.0.8 doesn't having any changes. So that's why it is showing like this. Okay, so now this image tag has been updated to second GitHub repository. So now what ArgoCD will do is like this ArgoCD will sync with the second GitHub repository. It will deploy our new changes. So ArgoCD will pull this new Docker image. Okay, so let me uh, open this 𝐶TL get pods hyphen watch. Okay, so last 57 minutes it is updated. So let me select in ArgoCD sync and synchronize. So here you can see currently app health is in progressing and it is synced. So here you can see a new deployment is creating and single pod is creating, and these two old pods will be terminated and new deployment pods will be comes to running state. Okay, so let me come here. So here you can see it new pods are in creating state. Okay, so now everything will be automated. So let's wait. So first pod and second pod is in running. So here you can see one pod it is in running. So we need to see one by one 6 pass. This pod, two pods will be terminated in some time. Okay, let me check once again. So here you can see one pod has been terminated, old pod, and this pod also will be terminated within some time. You can watch. So this pod should be terminated. So you can watch everything in ArgoCD. So here you can see in ArgoCD it will display in a beautiful way. So deployment it is creating and pods are creating. Let me refresh this ArgoCD. So let's wait, it is loading. So here you can see everything is green. So pods are also created. So let me check here, clear the screen. 𝐶TL get pods hyphen watch. So here you can see both the pods are active and up and running. Okay. So now let's see our end of the application. So this is the 𝐵J_GUID3.in, right? So currently it is displaying 0.2, but we need to see final. So when I refresh this, here you can see hello everyone from Google Cloud version final. Okay, so this is how you can automate this entire process using this DevSecOps approach. Okay, so I think you will like this project. So in this project we implemented a number of things, like we have created two different pipelines. For one is for application automation, and second pipeline is to provision Google Kubernetes cluster, and there we installed ArgoCD for continuous deployment, and we implemented Prometheus and Grafana for cluster monitoring, and we diverted our traffic to a GoDaddy domain provider, and we implemented SSL and TLS for our domain. So okay, we have done this many of things. Okay, so this is the final output. So this is how you can automate each and everything. Okay, so and yes, that's it for today's video. So now after completing this entire process, try to delete entire resources, guys. Okay, so now I'm going to delete GKE cluster first. Okay, so let me directly jump on to this pipeline and let me select here dashboards. So first I'm going to delete this GKE cluster, dashboards, and directly select here GKE-Terraform, and directly select here build with parameters. So directly select here destroy. Okay, and build. Okay, so now this will be destroyed. Okay, Let me open this in a new tab, console output. So here you can see cluster node pool, it is in destroying state. Okay, so again it takes nearly 5 to 10 minutes to destroy this GKE cluster. Okay, one thing I forgot to tell you. So after destroying this GKE cluster, it will definitely fail, guys. Why? Because means manually we have given node port for that uh, firewall, right? So in firewall rules, manually we have updated our node port, so that's why it will fail. So to avoid that one, directly jump on to VPC. So directly jump on to VPC network, and here this is the custom VPC, right? Directly open this, and in firewall rules we have given node port with name app. So directly delete that firewall rule. So here you can see this is the firewall rule. Only delete this firewall rule, guys. Okay, so we manually created this firewall rule, right? So that's why. Okay, we open this, delete and delete. Okay, so now this pipeline will not fail. It will be green now. Why? Because means why it will fail means we manually created this firewall rule, right? So that's why it will fail. Okay, so let me open this pipeline. Almost 1.5 minute has been completed. So I will show you this output in Blue Ocean. So previously we installed this Blue Ocean, right? So parallelly I will show you this output in a Blue Ocean. So let's wait. So after deleting this Google Kubernetes cluster, you can directly delete your virtual machine. Okay. So but please don't forget to delete these virtual machines. Okay. Why? Because means this Google Kubernetes cluster and these virtual machines will take more cost. So that's why I'm telling you. It is taking some time. So let's wait. So here you can see Terraform has destroyed all these resources using Jenkins. So here you can see now our pipeline is green. So now this Prometheus will not work. Our application also will not work. Why? Because means we have implemented Nginx Ingress controllers and everything, right? It will not work. This Grafana will not work, and Helm will not work. Why? Because means all this we installed on our Google Kubernetes cluster itself. Okay. So now let me remove this everything. So SonarQube will work, guys. Why? Because means we are running SonarQube inside a virtual machine, right? So SonarQube will work. So now uh, let me come here and let me check whether my cluster is terminated or not. Directly select your clusters or refresh this page. So here you can see we don't have single Kubernetes cluster, and let me directly jump onto VPC. So here we don't. So here you can see we don't have custom VPC. So all the private resources has been terminated successfully. So now we need to delete this virtual machine. So directly select this virtual machine and directly select here delete and delete. Okay. So now this virtual machine will be deleted. So after completing your labs, you need to delete each and everything. Okay. So now this Jenkins as well as SonarQube will not work. Okay. So here you can see both are loading, but it will not work. Okay. So let me close this. So meanwhile, let me so previously some load balancers has been created, right? So that load balancers also will be automatically deleted using GKE cluster itself only. So here you can see we don't have load balancers also. So let me jump on to artifact registry. So if you want to delete your artifact registry, that means artifact repository, that means Docker repo, you can keep this or else you can terminate. That is up to your wish. So if you want to delete this, you can directly select this repo. You can directly select your delete and you can directly select your delete. So inside this, you can see all your Docker images. Okay. So let's wait. So inside hello, you can see all your Docker images. Okay. So now if you want to delete this repository, you can directly select this and delete and delete. Okay. So now artifact registry will be deleted. So here you can see we don't have artifact registry, and let me refresh this. So it will be deleted. Cluster will be deleted. Okay. Here you can see overview and clusters. It got deleted. We don't have any single Kubernetes cluster. Let me close this. So let me see virtual machine. So here you can see virtual machine also terminated. So let me directly jump on to IAM. So in IAM we created service account credentials, right? So this is the one of the main thing you need to do. So after completing your lab, try to delete your service account credentials. So if you are keeping your service account credentials, so if you are keeping your service account credentials, uh, anyone can access your Google Cloud account. Okay. So directly select this and delete and delete. Okay. Let me refresh this. So here you can see successfully we deleted our service account. At last we created a private, a VPC network, right, for our VM provisioning. So let me delete that virtual machine also. Directly select your VM instances. Sorry, we created a VPC network, right, for our virtual machine provisioning. So directly I'm going to delete that VPC network. So here you can see project VPC. So directly select this and delete VPC network and copy this name of the VPC, copy this project VPC and delete. Okay. So here you can see currently it is in deleting state, project VPC. So let's wait. It is deleting. So here you can see our project VPC also has been terminated successfully. So we terminated each and everything, guys. Okay. So, and yes, that's it for today's video. And if you like my video, please do like, share and subscribe to my YouTube channel, guys. And see you in the next video, and bye.